Well, hey there. Welcome to SkyTour LiveStream for today, March 5th, 2019. Theoretically, only a couple of years from the James Webb. And on the line with me here, actually here in the SkyTour LiveStream studios, if you want to say that, is Keith from P&K Space Imaging, now known as P&K Science. What's up, brother? What's going on?
Same old, same old.
Same old, same old.
Tonight.
What's that?
Said I'm going to sit here and chill tonight.
Very good. Well, that's okay. I'm not sure how long this stream is going to go. We actually have some clouds coming in. But I said if I don't start streaming soon, we won't be able to get a look at some cool things before, I have to shut it all down. So we're going to get it done sooner than later. So
what's the forecast look like?
It's going to be mostly cloudy by midnight. And I see some high clouds coming already. So I do not like this. I do not like them, Sam. I do not like high clouds. So
and people in the chat, don't forget to tell us how the sound is to make sure we're even. If I'm too loud or Mark's too loud, and tell us. That way we can adjust if we need to.
That's right. So I can just make the appropriate adjustments. I think that our levels will be okay. I think we're
yeah. I'm worried more or less on my end, just if it's high enough or low enough. Because I constantly have to switch mine, like when I'm doing the video editing stuff, I have to up and down. So it's different for everybody. So I just want to make sure I'm not like overly loud or too quiet.
Okay.
Because I know we're on the same channel, right? Me and you.
Yes, we are.
Yeah. So I just want to make sure I'm not too loud.
All right.
Mark,
fair enough.
Sounds great. So good. Awesome.
That's really good. I'm happy about that. Yes, we are. And that's excellent. So now I will. Just move a few things here. Here we go. Ta-da! All right, and now we can do this. Actually, some things have changed. We actually, Dr. Mark from Texas, welcome to the chat. It's so nice to see you here. Dr. Mark and I shared a common background of medical history, and he is back in the saddle, as am I, and so I'm really pleased. It's wonderful to see you here, Dr. Mark. We haven't even actually got to chat on the phone, but we will. Maybe we'll have you as a guest on here sometime if you want.
Mark from the next person, but if he's getting the plus from you, he's all right by Mark. You know what I mean?
Well, there you go. Yeah, hey, Marianne is here. How you doing? Thank you for coming. MTX 303. Thank you for letting us know about the sound, and welcome. Evan Dincher, welcome. Maddie, hello. Maddie was wonderful yesterday. Maddie gave us like $45.
Jeez. Wow.
Yeah, I mean, that was like, these guys humbled me out here. It's like, just when you think you've seen it all, then someone comes along and does something spectacular.
I like the way YouTube has set that up.
Yeah.
I really have. I mean, because of the fact that you can support the creator,
Yeah.
So I just like the fact that you can support individual creators if you want to, if you enjoy their content. It just makes all the difference.
Yeah, it's really nice. I mean, and I think that that policy from YouTube is actually a good policy. By the way, you may be wondering what's going on here on the screen. That's only because I have a pair of clusters up here that I haven't actually imaged yet. They're actually, you can see them on the screen. And I'll just move them up a little bit, moving the telescope. And if you have eagle eyes, you'll actually be able to see in the telescope view. You actually watch the telescope moving very subtly. When we make the major moves, you'll actually see it because this bottom camera is riding along with the telescope, and this one here is on the inside of the observatory looking up at the telescope that's up in the air over it. So this would be kind of cool.
Let me ask you a question just so you can explain to anybody that doesn't know.
Sure.
Why is red good when it comes to astronomy?
That's a very good question. And you'll notice in the dome ops view we have red. I have the red lights on in my office. I actually have they're Wi-Fi programs, so I can just yell at Siri to change the colors to anything. I can actually now watch, it won't work. Hey Siri, turn the lights blue.
Getting in touch.
There you go. See? So now the lights are blue. Hey Siri, turn the lights red.
Getting in touch.
Yeah, thanks for that, Siri. Yeah.
All right, then.
Turn the lights red. Okay. I'll, I know, right?
That's it. I'm off the clock.
Set condition red. Okay. Well, there you go.
Technology.
So blue it is. No.
You know what? How's your CPU usage? Because I don't want to. I noticed that the Skype, since I'm viewing live from Skype, it's a little sketchy. It's a little.
Well, it's CPU's at 35%.
Okay.
And if
Just
you
wanna
notice,
make
the kilobits per second, that is the throughput here, is at, well, it's like it's 3,300. It was just at 4,000, then it dropped to 2,900. It seems to go back and forth.
That's why I was asking.
No, fair enough. I want to make sure that we don't have any problems. We actually hardwired this now, so.
Yeah, the mic is great, but see, when it comes to the encoder,
yeah,
yours is overloaded. So actually, you would want your computer to actually do a little bit more of the work. So if you went into settings and went into output or whatever it is, you know how it has like fast, faster, very fast, super fast.
Yeah,
I'm not sure what you're on, but you can probably go down to another one.
Where are we at? And under output?
I think it's on output. It might be on video too. There you go. Yeah, you're on very fast. So you can probably go down to yeah, you want to click on there. You go down to faster.
All right, try it out.
See if your computer likes that. And now it'll make your CPU usage go up, but because you're sending like really high definition video,
yes,
that encoder can't keep up with encoding that to send it out through the live stream. So it's asking your computer to do a little bit more. That's what happens when it says encoder overloaded.
Yeah, that's good. So now we've I don't see the message now, so it's gonna have to sample. Don't mind us, friend. Don't mind us, folks. We're just trying to get the thing working properly the way it is.
You're lucky. It looks like yours took, like when I do that, I have to actually just hit stop stream real quick and then hit start stream. And usually people can't tell, but I usually have to do that in order for it to, but looks like yours did all right.
Yeah, it seems it, huh? Seems it.
Looks good.
Yeah, very cool. I'm liking it a lot. So,
it did go back to red.
What'd you say?
I said it did go back to red.
When?
Your light and your dome ops.
Oh yeah. I changed it. I went in. I actually went into the phone, which is connected to the Wi-Fi lighting system.
Oh, okay.
Yeah. When I do those TV productions, the guys come in, the lighting guy comes in, and he says, "Oh, I want to add like some blue to the room. I don't know. I want to add like a blue color, And so I say, "Hey Siri, set the lights to light blue," and it goes to light blue, and he goes, "Oh." That's so funny.
Stick birds up.
I should have been careful about saying that.
Why am I hearing myself through the microphone? Let me see here.
Well, it ain't 'cause of me.
Yeah. It's like, no, now it's not doing it. I thought it was maybe because I went too loud or something. But yeah, the LEDs I think are great. Like, they really come on the market now where they're really cheap. And I actually took a strip and I put them behind my headboard of my bed. And then I have it on a low setting, so behind my bed it actually illuminates, whatever color I want. So I usually switch it like once every couple of weeks or something to a new color.
Yeah. Hey, Laura. Laura's here. Laura Newbert. She posted the ABC show link that we did. They came here on a Thursday and then went to Doug Trumbull's on the Friday. And I talked to Doug, and actually they were going to just do my segment. They didn't even know about Doug. And I told them about Doug, and they were like, "What? We can talk to an Academy Award winner?" I go, "Hell yes."
Right.
And so Doug and I got together the next day, and they were there, and they were just like blown away by everything that we've done up in the studio, which is really cool. I mean, it's really a skunkworks for film, and mostly, I'm in it obviously for the cameras and the UFO side of things with Doug, but I also work with him on commercials and TV stuff, movies. But the bottom line is this: the ABC crew, they did a really nice job. The editing was just unbelievable.
Yeah, and it didn't get campy.
No, the guy was
How it goes every time you like do an interview about UFOs or anything, like they get campy, like haha, little green men floating around the sky, blah blah blah. It didn't do that, which I appreciated.
And usually the hosts do that.
Yeah,
if the person doing the interview doesn't, the host will do it. Ooh, well, let's be careful not to, get abducted by little green men when we go home tonight. There, right, Sally? Yeah, you're right, Frank.
Yeah, like that ending smarky little remarks.
Smarmy little remarks. Yeah.
I said smarky.
Yeah, that's kind of cool, actually. Yes.
Oh, you know what? Here's the thing. Has that school ever decided about that dome or what?
Yeah, they have, and they're gonna. I think they're gonna take the dome. They just have to see the photos, and whenever you have time.
If they don't, I have somebody that might.
Oh, well, now you're talking. What do you got?
He has an area, and he's thinking about actually setting up a dome there.
Where's this?
So, because he's been talking lately about going to a 14 or 16 inch.
Okay.
And he realizes that because the only reason we don't use the 12 a lot is because of the wind. Anybody that doesn't know this, when the bigger scope you have, every little thing affects it, which is why he complains a lot about the traffic in the parking garage, because that little vibration, when you're zoomed in that much, it is totally affected. The littlest bit of wind is totally affected. It makes the camera shake.
You can't walk, because if you walk, then you see a little boom, boom, and you see the telescope vibrating a little bit.
So he asked about that dome. I said, well, last I heard they wanted it, but I wasn't sure if they decided to take it now or if they're not going to take it. But he said something about asking you about it. So
okay, well so
if that falls through, just keep them in mind.
I will indeed, because they're actually they were kind of testing my patience a little bit, because I really like the idea of doing something good for the school. They're a good school. I really appreciate them. They're my friend, of course, my lifelong friend works there, and so I was trying to do something for the school, and it's a school with means. It has some endowments and stuff, and so I said to them, I've got this dome, and I'll send it down to you. You can turn it into a project. The kids can actually work on it, and it'll be a really good project for them to work on. And then they said, oh, great, send pictures. So I sent pictures, and when I sent the pictures, then they came back and said, well, is it in that good a shape? I'm like, well, I mentioned it as a project. It's a fiberglass dome. You can't kill that, So we'll see. I mean, I don't doubt that they're going to take it. I think they're going to be very happy with it. I really do think that they're going to, be very happy and take the dome. But I'll let you know.
Sounds good.
Yeah, I'll let you know.
Sounds good. Let you know.
Yes, I will. So this is a little cluster that we're looking at, and if you're wondering what that is, let's go over to our planetarium view right now and just take a quick look. We're over here looking at NGC. Gosh, I can't even read the writing. Okay, 2383. Right, and then NGC 2384. These two little star clusters, and we're gonna check them out. Oh, come on, man! Really? Did you just do that?
Maybe.
Why'd you do that?
Because
that is just so amazing. You're incredible, man. I asked you to come out with me. I didn't ask you to donate money. That was so cool.
Well, no. See, we had something called a really good lunar eclipse night.
Yes.
And so happened our ad revenue was on that night, so I figured I'd spread the wealth to science channels. So you won't be the only one.
Oh, okay, cool. Yeah. No, I'm glad you made out well on that night.
Yeah, we were lucky enough to have.
Gosh, you had like how many million hits? I mean, how many views?
Almost 2.7.
2.7 million. Yeah. Oh my gosh, it makes me crazy. I can't believe it.
And notice I had to add poo poo pee pee in there just.
I see that. Yeah. Yeah. In his Skype logo, folks, in his name, under his name, it says poo poo pee pee. I don't know. Just
that's my immature calling card.
That's his calling card. Immature or not, it's appreciated. That was very kind. Thank you, man.
Yes, sir.
Wow. So I'll do 15 seconds at 4,000 here on these two clusters just to check them out. Oh, that's so cool. Look, you're stuck at the top of the chat now. That's not going to go away.
Nope. And hello, Dagger. And yeah, that night was absolutely crazy. And Raymond and Maddie and, of course, Laura, you mentioned before.
Yeah.
Yeah. Yeah. It's a great Tuesday night.
Yeah, we have a few people in. You know, we have Dagger Spells is here. Ian McQueen. Hi, Ian. How you doing? And Maddie, of course, donated to us the other night. It was beautiful. And then Raymond B is here with us. And, of course, you, Keith. So that's really cool. And I know that we're just getting started for the night. Hopefully, we're not going to get clouded out. But I do know that clouds are on their way. So we'll see what we can do. You know, so you can see this little cluster over here. This is a beautiful little cluster, and you notice it kind of looks like it's farther away because it's smaller and the stars are finer looking. Well, they don't have to necessarily be farther away, but in this case they are. Okay, it's a more distant cluster, and these stars did form all together. They're approximately all the same age. That stars that are actually in the cluster. Stars like this one here and this one here, these are all stars that are either further or closer to us, not the same. And usually the stars that form in a cluster are all the same relative type. So there'll either be all hot B stars or hot A stars or F stars or so forth. They don't tend to be many different varieties. And only after they evolve for a long time do they change into something else, like a K star, say like this one here over here, which is a little more orange. All right, so that's what we have there. So let's. I'm noticing a little red tint here, so I'm wondering if we already have any cloud issues. But you know what? I don't care. We're gonna keep going and see what we can do. We'll have some fun.
Excuse me if I wasn't paying attention. What area of sky are you under?
I'll show you. Okay, as we zoom out. Okay, you'll see that we are right to the left of Sirius, which is right there.
Okay.
All right, and if we were to come up to, let's see, let me go up here. There's a nebula right here called the Seagull Nebula. I want to let's see if we can see this dark lane in the Seagull Nebula tonight. The nebula is not terribly bright. It's not terribly dim, but it's not terribly bright. So what we're going to do is we're going to go here and see if we can capture that little area just for fun.
I'm going to have you print me an Aristarchus plateau, the biggest one you can make.
I could do like I think a...
What that calls me?
10 by 10.
That's awesome, yes. That would be awesome.
Well, I don't know. I mean, let's see. Geez, someone gave me a $50 donation tonight. You
see so many of these 3D printing creators before. Seriously, I'll pay for it. Like if the big one you can make of the plateau.
Yeah. Well, you definitely need one.
I know. That's like my favorite area.
It is. I mean, you talk about it so much. Do you want? It's Herschel crater next to it, isn't it?
Herschel and well, that's all. Well, Herschel's part of the plateau, isn't it?
Right.
Kinda?
So you want all that. So Aristarchus and Herschel, yeah.
Yeah.
Yeah. That's probably a good call. I'm jumping up to like 20,000 ISO, and we're going to go to 20 seconds here. Just want to see what kind of night it is. And you might, you see 20 and 20, and well, that just happens to be sort of like a little magic spot where the noise induced by a 20,000 ISO sensitivity is high, but not nearly as high as, of course, 51,200 or 40,000. And it's sort of right in the mid-range there, and it's kind of almost usable. The highest maximum that I tend to use is about here, 25.6. But I will use higher sensitivities fairly often to just get spot shots of something.
Do you see our friend Ian's question there?
I see it in the chat, and I'm just gonna get this photo underway, and then I'll check it out.
Hello, Ted.
And hello to Ted. Yeah, he just joined us. Okay, camera is underway. We got the photo underway. So now, Ian says he's got one. Okay, do we have a specific value that separates when a collapsing star? Well, actually, yeah. When a collapsing star becomes a black hole. In other words, if the star has 1.44 solar masses, that's called the Chandrasekhar limit, and that is a limit at
Say that again.
1. Chandrasekhar. Oh, that was a mess.
A little fast. I just couldn't.
Yeah, I'm sorry. I'm going a little fast. If a star has 1.44 times the mass of our sun, okay, that's the Chandrasekhar limit, and that's a very magical number, because that number is the number where a star, if a star like the sun dies, it becomes a white dwarf. If it gets more than 1.44 solar masses that accrete onto its surface or land on its surface, well, and that's usually in a binary star system that can happen, then the star will actually have will actually explode. It will do a supernova, and that's the special supernova type 1A, and that is when that mass on that white dwarf will increase to beyond 1.44. Okay, now beyond the 1.44, then what's left behind could be something more. It's obviously more massive. All right, and that will tell us that's also something that could be, a much more massive result. I'm caught between two things here, so I'm trying to do a couple things. So I'm going to drop this to 16,000 and leave it at 20 seconds and get going there. Yeah,
just
sorry.
Daily trivia. What does ISO stand for?
That's International Standards Organization, and it's actually a standard by which they try to create categories of sensitivities for cameras. So the ISO is that. It used to be ASA, which was American Standards Association or something, and that was also sensitivity. All right, but the sensitivity and the when international, of course, then it became ISO instead of ASA. So that's just the way that worked out.
Matty was wondering about your interview with Thing. He's from England, and for some reason, it wasn't available in his country when he tried to click the link.
Well, that's weird.
Is there a
Oh, Ted, thank you, man. Look.
Poo poo pee pee squared.
That's pretty good. Thank you, Ted. Holy cow.
You did.
It's
a really good interview, but I mean, it'd be kind of crazy if, like, who was that? ABC, NBC?
It was ABC, yeah, out of Boston.
It's hard to believe that they would restrict, just the United States, but maybe they do.
That's a good question. I don't know. It maybe has to do with, I don't know, when they actually, I don't know what the word is, but when they license.
Do you think that they would allow you to post it on your channel since you were involved with it?
I see. Bill played the interview yesterday on the stream, and he had to delete it because he was going to get a copyright violation on it.
Well, I mean, if you ask them, if you say, hey, and they give you the paperwork saying, yeah, you do have permission to post it.
Yeah, I would love to post it,
Yeah.
And I just don't know if it's going to give me a community strike or something,
I'll tell you what, I have a throwaway channel for stuff just like this. I'll upload it.
You do, don't you?
I'll put,
oh, God.
As many strikes as it wants. Because, dude, I have like 6 channels. So, like, I have the P&K, of course, and then I have Paul's intake channel.
Yeah.
I told you what I was thinking about doing before with that intake
giveaway.
channel.
Yeah, giveaways.
Yeah, build it up so it gets all the parameters that you need to be able to monetize and whatnot, and then give it to somebody that wants to put out content and put ads on it and stuff. That way they don't have to go through the trials and tribulations of building a channel.
Yeah,
you still have to get subscribers and whatnot, but your watch time and everything will be taken care of.
Yeah,
so
that's all good.
Like Doty.
I'm just messing with the photo we took. Okay, I got to turn off. Had a little sharpening going on there, which I don't want.
Size of the pixels in that.
What's that?
I said you could actually see the size of the pixels in that.
Yeah, which is not necessarily a good thing, but I'm trying to.
It's one of the down. I mean, believe me, with the camera that we use, That's the one downside, is because ours is set up for close moon viewing. So when we try, even when we go to the 80 millimeter,
Yeah.
I mean, the pixelation, you just see it because it's not set up for that. But it does give us a pretty good picture. So we can't really complain.
No.
We're getting really, I mean, Paul's getting really close with the infrared.
That's good.
Yeah, I know. I just posted a video earlier of a couple objects. I think the first one was a satellite. The second one,
I saw it. I watched it.
Rating data for that one might be space junk. Not sure.
I watched it. I saw that the satellite. It was nice. I wish that you had what's his name's tracker going at the same time.
Oh, see, here's what's going to happen. I'm going to have to end up going down, stopping at Astronomy Live, or meeting Paul there, and then having them because of the way the software is set up.
Yeah.
You don't want to use your main mount. You want to test it out on like a smaller one. So I'm thinking like if he did it on the 8-inch HD or something, and test it out to see if it works. Because he does a really good mount for that as well. So yeah, maybe that'll work out, and that'd be cool if he could just hit a button and it'll automatically track it. I mean, he did pretty good though for tracking it by hand with a telescope.
Yeah, absolutely, he did.
And the thing was, I had to put out that video because those actually happened off stream. Like that one happened right before we went live, the second video, and then the other one, I don't think we were live that night. I think we were just tinkering around with the red. But yeah, and everybody that asks, yes, it's infrared, but yes, it also is an image intensifier. Like it intensifies the light and stuff. So yes, you will get those little sparklies.
Yeah, the center is usually the center of the tube is generally got those cascades going on where you get those little extra flashes. I have one of those, which is an ambient light intensifier, and I got it from a company in California that had surplus military gear.
Yeah, that's what see. Paul's ordering things like because he's trying to find like the perfect lens for it. Like he wants to have a 3-stage. He wants to have a really wide field.
Okay.
And then he wants to have like the medium, which is what we've been using lately. But then when he hooks it into the scope, like, dude, we were broadcasting the Orion Nebula like live.
Sure.
In infrared, and it looked good, and there was detail to it, and I was like, wow, this is really neat.
Yeah. And like with this camera, if I go and click this button here, it brings us to the the 4K mode, and we can actually then capture things live, and if I increase the value of the ISO, well, then we'll actually see a very, very bright object, an image. I'm looking at, this is white, and this is not supposed to be white, so I have to go outside and check to see if we've got clouds already. So can you keep the ship running? Keep the ship running while I go look at that. All right, I'll be right back.
Check. Ladies and gentlemen, once again, we are testing to see if there is some haze or clouds in the area. While I turn on my radio voice. Okay, I'm done. And hello, Ian and Maddie once again, and Laura once again, and Charles Smar probably. Sorry, Charles. I should have asked you when I saw you up at Bill's how to actually pronounce it. I think it's just Smar. For some reason, I was calling you Schmar for some reason. And of course, Ted and Michael and Raymond. So yeah, it's a night just hanging out, as you can tell, since I'm on. A little less scientific, a little more hang out, if you know what I mean. But here it goes. Bada boom, bada boom,
bada bing.
You got it.
Okay, well, we do have clouds out there, but.
And once again, I'm Keith from P&K Space.
Yeah, I was about to actually go through that. Yeah, you're committed, of course, to a few institutions, but I think it's kind of cool, and I think that the folks that are here tonight appreciate that you're here as well, without a doubt. And we do have clouds tonight. Like I said, they just showed up, so.
I was just explaining to people that since I'm on tonight, it's a little less scientific and a little more just kind of hang out.
Well, that's okay. That's okay.
I still do
stuff, and
wayward science.
Well, it's not wayward. I mean, you're not like
Well, I'm not like an expert, you know what I mean? Like, you know how you have like Mark's an expert on everything, and you know, you have Daryl's an expert on pretty much all things astronomy. So, you know, I'm just kind of here as a, you know, secondary, as a friend. I'm here as a friend.
I think it's great. I think it's great. Now, even though we have clouds, I think we can actually manage to view some of the clusters.
Yes, it's the same thing that I said with Bill's channel. Like, a lot of people come here not just for the imaging itself, but the camaraderie, the, you know, the hanging out.
Yes.
The friend, the chit chat.
Yeah, exactly. Absolutely. You know? And that's actually a good thing.
Which is what I kind of miss about being a smaller channel. Because, you know, you did have it. Now you just get, you know, you go live. It doesn't matter what you're live streaming. You just get drowned out by, you know, a bunch of people. And I understand that. You know.
Yeah.
But what can you do?
Yeah, I know.
I'd rather have, you know, 40,000 eyes looking at something than 10.
Yeah.
You know what I mean?
Yep, I do.
And people are always catching stuff. That's what amazes me.
You do. You have a lot of people that are watching, and I wish you had been in position to capture the meteor strike at the eclipse, because you would have had people actually see it in your chat.
I know, and it was just such bad timing, the fact that we were at a low exposure at that time, because we were trying to watch the Terminator cross.
Yeah.
You know, and it was just happened to be that point, you know, when that meteor hit, and then, go figure.
Of
you know?
Course.
It happens.
It does.
But hey, everybody else got it, so that's good. I mean, at least we were able to corroborate it with, you know, you and you know, Astronomy Live and Astronomy LiveStream and you know, among others. So.
Yeah, there were a few of us that caught it. You're right.
Yeah, and the Griffith Observatory. You know, those were the 2 points I went to. I went to yours and Griffith, and the times matched up perfectly. After figuring in the 30 or 10-second delays that each of you had.
I mean, I had someone trying to tell me that what we caught was not a meteor; it was something else, and of course that they disappeared into the woodwork as soon as we got the confirmation from everybody else.
Yeah, but you're gonna have that. I mean, that's just, you know.
Yeah, it's the way
it's the way of the
it is the way of the troll.
Well, thank you, Raymond.
Raymond, check it out. Hey, man. Hey, thank you guys. This is fantastic. You guys are really, really being good to SkyTour LiveStream, me and everything. That's good. You know, I'll tell you why. I have a few systems I'm adding to the observatory, and with your donations, I'm gonna be adding them. I'll be able to do that very soon now. I'm just that's outrageously cruel, man. You know, I don't know. You guys are gonna have excellent karma, you know, for doing this.
Have you ever thought about or maybe you have already? Do you have like a camera that's able to shoot infrared?
I do actually. I've got a camera that I actually converted to be very sensitive to the infrared. Because every 35 millimeter camera, and I'll just tell folks this, because in case you don't know, some of you do. 35 millimeter cameras, the ones you buy that have the lens that can take off and put new lenses on. Ew, that's ugly. Had some drift going on there. We're gonna do that one again. Hang on. Those cameras actually have a filter that sits right above the sensor. It's a piece of glass, and it usually is a combination of a UV filter, ultraviolet, and infrared. And the infrared filter is called an infrared blocking filter. And the blocking filter's purpose, of course, is to block or remove the infrared component so that you won't get a pink hue, because the infrared's down in the red. And if you let it leak into the sensor, it will make all your images look pink. So of course, I have a camera body that I want to use for doing spectra, and that camera body is it's a Nikon D something, D80 or something like that, and I have a D90 mounted on a telescope now for spectral purposes, and then I have our Sony high-end camera that's mounted to the main focus to show us these images we see here. And the spectral that blocking filter that I was telling you about, I did a little surgery on that camera, and I removed the blocking filter.
To get out.
I took it out.
Camera.
Yeah, and now I have a camera that can see into the infrared. And there's an interesting thing that happens when you do that, and that is this: when you look at the sky with this filter, okay, you see more into the infrared than the camera normally lets you see. So when you're doing things with like a camera, take photos like the one we have here on the screen. Okay, this is a star cluster in is this Puppis or Canis Major? This is, I think, is this Puppis? I think it's Puppis.
Yeah.
Okay,
Puppis.
and this is the and this is the cluster M47, M46. It's M46. Okay, and MSU46 is an interesting cluster because in that cluster you see a dying star here. Well, but this cluster is a young star, so how is this dying star there? How did this happen? How do we have this kind of evolution thing going on here where we have one star evolved faster than the rest? The answer is no. It didn't. That star is actually in the foreground. It's 2,000 light years closer to us than the rest of the cluster. You'd go zipping by that thing and continue on to the cluster. So it's pretty cool. So anyway, with the infrared systems, when you do things like this, take regular photographs, you won't really notice too much of a difference other than that you will get more of the reddish part of the light. And you'll end up color compensating it later when you go and play with it in Photoshop or whatever.
What's the difference between that and like a full spectrum camera?
Well, a full spectrum also reaches out into the ultraviolet a little bit too at the other end. But if you have a camera like this one where you just remove the blocking filter, then when you do spectra, okay, where you actually have a grading like I've gotten on our spectral camera, and it breaks the light up into the rainbow of colors, we'll see that actually is where taking out that blocking filter and allowing more infrared light in makes a difference. Now, first of all, infrared light really doesn't like to go through glass, and it doesn't really like to come all the way down to the ground generally. That's why telescopes that look at it are high in mountains or in space.
Yeah.
So by looking at it without the blocking filter here on the ground through a camera lens that's in glass, we get some infrared, but not a whole lot. We don't get much of it. So that is what happens without the blocking filter. But that when you remove that filter, the cool thing is that when you do the spectra and you see the spectrum, the rainbow of colors, and we've talked about this before, different chemicals in the atmospheres of stars will cause some of the energy from the star to be basically sucked out of the spectrum. And that shows up as a vertical dark line. We call it an absorption line because the outer atmosphere of the star is actually cooler than the interior, which is millions of degrees. All right? And the outer atmosphere being cooler means that now we have hot energy from within traveling through a cooler gas on the outside. The cooler gas absorbs some of that energy. By absorbing some of that energy, it causes a dark line in the spectrum. And for certain chemicals and elements like hydrogen, okay, and other elements, all the other elements, that dark line appears at the same exact spot every single time. All right? And so we can identify what stars are made of by just looking at their spectra. When we look at this thing right here, this is a planetary nebula. It's the remnant of a dying star, as I said. If we look at this, all right, right here, you'll notice it looks a little greenish blue, right? Mm-hmm. Well, if we look at it and take the spectrum of that, we'll see that this is actually emitting a bluish-green light, which you can see with your eye, all right? And it's actually the light caused by excited oxygen atoms that have been shed from this star right there in the center, which you can see, dead center in there, all right? And the star is a hot white dwarf, and it has ultraviolet energy that's exciting these oxygen atoms that used to be in the star's atmosphere. And so by exciting them, it causes them to glow. And this glow is exactly what we're seeing here, this blue-green color. It's the light of what we call oxygen-3, which is doubly ionized. That is to say, 2 of the electrons are shot up to a higher level in the oxygen atom.
Like so excited for the James Webb.
Oh, can you imagine? James Webb is going to be like tremendously prolific. It's going to show us amazing things.
By the way, anybody listening that's from that is subscribed to us over at P&K, the next time Mark comes on, which will be the next moon cycle, let's see, the new moon is the 6th, so I'm guessing it'll probably be the weekend of the 15th, 16th, and 17th. We are going to go way in depth with the James Webb Telescope.
Oh, that's going to be great.
We're going to show everything that it theoretically can do. We're going to really dive deep into it from beginning until now, and
we'll talk about all the instruments on it, too. I mean, the James Webb is primarily an infrared telescope. But you know what? If the Spitzer Space Telescope is any measure of what we can see, the Spitzer Space Telescope has found so many incredible things with its infrared. It's an infrared telescope. It's looked at the universe, and we've seen the infrared universe like never before. We've found planets with the Spitzer Space Telescope because the soft glow of planets in the heat range can sometimes give them away, and the Spitzers found that.
Size between the two of them.
Well, yeah, I was going to say, the Spitzer Space Telescope's mirror is like 2.9 feet in diameter. 2.9, not even like 3 feet, roughly, not even 3 feet. And the James Webb Telescope is 21 feet in diameter. Yeah, we're going to see a very different, result, let me tell you.
But, I mean, you being an exoplanet specialist, I mean, that's what you specialize in for your astronomy.
That's what I chose to specialize. Yeah, it's beautiful.
To be able to say, hey, we're going to be able to look at planets around other stars and actually tell their makeup.
Yeah.
That's insane.
It is. And you know what? Here's what's interesting. Back in the 90s, it was Carl Sagan, my favorite astronomer, Carl Sagan, who said of the Galileo mission, which was then heading to Jupiter, could you please turn Galileo around and have it look at the Earth so we can see what the Earth looks like from Galileo? And they were like, well, what will that tell us? Well, the idea was that we would see what a vegetated planet looks like through the eyes of the Galileo probe. And they did that. And as the Earth rotated, they got different images, the Sahara, the ocean, the cold, Asian reaches, then the Amazon basin. And each of those locations looked very different. And they actually used something called the reflectance index. Okay? It's not quite the same as reflectivity, but it's for all intents and purposes, think of it as a very interesting segment of a reflection, okay? And that was able to tell them, without a doubt, that certain types of vegetation and landforms look the same with certain instruments. And the James Webb is going to have those instruments. So it's going to be able to look at the reflectance of planets thousands of light years away.
I didn't think about that.
And it's going to be able to say, hey, there's plants on that planet. There's plant life there.
On other stars.
Isn't that wild?
And the closest one being, what, 4 light years?
Well, Proxima Centauri's planet is 4.2 light years from us.
Michael Weiss asks, are you adopting any electric universe theories? I can only speak for myself with this. I find it very interesting, the electric universe theory. It does have some very big holes, and some of the answers that it's giving are kind of flawed, but I do find it interesting. I don't know what you think about it, Mark.
I don't. As far as I'm concerned, the electric universe theory is not necessarily wrong at all. I think that everything in the universe we look at in the universe, everything, is based on frequencies, is based on vibrations that are going on in the universe, everything. So therefore, I think it makes perfect sense to at least consider that there is a very possible or possible connection with the way that the the universe looks, the way the electric universe looks. You know, in a way, in fact, that I would say, I guess, the frequencies, I should say, are you know, all come together in the way that in the way we would expect to see the universe. And I know that barely made sense. I was doing 4 things at the same time I was saying that sentence, so I apologize. But the truth is, when you look at the way, like I said, the frequencies we see, everything we see out there, frequencies, okay? And when we look at, say, the Orion Nebula, okay, we are seeing a lot of very interesting things. Like, here's the Orion Nebula. Okay, now, the Orion Nebula has these areas in it. These areas are, let's see, let me zoom a little. These are images we took within SkyTour LiveStream with our telescope. Okay, these areas right here, especially this area right here. Okay, this is an area that is ionized gas. Okay, this is an area of ionized gas as well. This is ionized oxygen, and this is ionized hydrogen. Okay, they make different colors to the eye or into the cameras. Okay, but you know what? They all have to do with the frequencies of the atoms in the gas. Okay, and the energy levels, which you can relate to frequency. So I guess in the sense, we can't say that electric universe is necessarily wrong. It's another interpretation, you know. Same thing with the Pac-Man. This is the Pac-Man Nebula we shot here as well. Okay, this is a hydrogen gas region, an emission nebula. It's giving off energy because the stars in here, in fact, it's really crazy. This is a very interesting dark cloud here. This is a dark molecular cloud. Looks like you know, the brain of Pac-Man here. If this is the eye, okay. This is a dark little cloud that's sort of isolated, and now that's a cloud that has atomic hydrogen in there and molecular hydrogen. That is 2 hydrogens connected through a bond, H2. Okay, and then it has dust, which is making it opaque. Now, this is this too, and this is what we see in the universe. A lot of this stuff, and these are excited atoms that are actually out there. You know, they're vibrating at specific frequencies. This dark mass here, this dark dust, again, specific frequencies and sizes. Everything interacts with energy, okay, and the energy results in frequency shifts. So I can't say it's wrong, and so I don't necessarily come down on it. I used to, but I don't anymore. And more from our greatest hits. This is the Trifid Nebula. This one is a nebula that's an emission nebula, and it has the dark dust lanes in it, okay?
It's crazy looking.
Yeah, and then this is the Blue Nebula at the other end of it. This is actually a very distinctively different color than the Oxygen 3 Nebula that you see in the Planetary Nebula, and the one we saw in that round one earlier, and then in the Orion Nebula at the edge. Okay, this is not an oxygen nebula here. This is actually a reflection nebula. The star here is actually reflecting, it's starlight reflecting off dust grains here. There's dust grains here for sure, probably a similar amount, but the star is also more energetic, and it's causing the star's hydrogen to ionize, and then when those electrons jump back into the atom, they lose energy and give off this red light. That's what we see, and that's what we call an H2 region, as in Roman numeral 2.
And there's that red again.
And it's red. That's right. You know, so you know it's all about that. Now, this here is another one. All these are from our greatest hits from last year and this year. This is the Bubble Nebula. This is a very interesting location because the star that's causing this, okay, not necessarily, I don't think it's this star. I think it's like this little guy right here, maybe. The star that's causing this bubble is a very special kind of star called a Wolf-Rayet star. Now, those stars are very powerful. They're very massive, and they're very powerful, and they have very, very high stellar winds. And they blow stuff, man. They blow this stuff out, the gas, and they actually snowplow. This thing is snowplowing into other material out here, and that's why you see the edge like this. And you know, the gas is ionizing. Well, it's going out here too, but you don't really see it too much because it's got less to encumber it over here than over here. It's going into denser material here. So it's really cool stuff.
Look how many stars are just in that single image alone.
Oh, I know.
The structured stars.
I know. Isn't it crazy?
Think that there are planets most likely around every single one of them.
Almost all of them, yeah, for sure. You know, maybe not the hottest and youngest, but certainly around the older. In fact, most of the stars actually the vast majority of the stars in our galaxy, you think you see a lot of stars. When you go to a very, very dark sky site, you see the Milky Way over your head. It's like, wow, horizon to horizon stars, right?
They've been seeing half of them.
And half. You haven't seen a tenth of them. I mean, what you're looking at is just a very few. The majority of the stars in the universe are so faint you can't even see a single one with your eye.
Did you see that I'm not sure which craft took it, but that massive picture of the Milky Way. It was like something like billion pixel or 30 billion pixel.
Oh yeah, one of the gigapixel shots.
Yeah, that was insane.
Yeah, you know, it seems like you'd zoom in forever, you know.
Yeah,
and it's like the Lunar Reconnaissance Orbiter, you know, when you go down to 0.5 meter per pixel, you just keep zooming in on the moon, zooming in, and finally it ends, and you're almost glad it does because you're going to feel like you're going to crash into the moon otherwise. You know, you get so close.
I mean, just some of the stuff they come up with. I mean, this is what for the people in the U.S. anyway, this is what your tax money has been doing, you know.
Yeah.
The LRO is just as the amount of data just gained by the LRO in itself.
Oh, I
know. Not just visual data, but you know, they have the topography.
Raymond, what are you doing, man? Let's check it out. Darkroom usage fee. Raymond, you're awesome. Raymond B, you know what? It's a pleasure having you here, man. Not just because you donate, but because you actually have good questions. You talk. You talk about pretty cool stuff, man. So thank you very much. Wow, that's cool. You know, and speaking of darkroom, Raymond, this object here, okay, I had to tease this out of the shot because it wasn't so visible. But this is actually another nebula generated by one of those very hot, bright, odd stars that are called the Wolf-Rayet stars, also known as WR stars. Very, very hot, you know, and the star is something like right around here. And it's just blowing this gas out, and where it hits other material, it spawns other stars. It's just an incredible amount of things going on here in this image, you know, and in this location. And look at all the stars here, Keith. You know?
Crazy.
Yeah.
Well, okay, listen, let's crank the optimism up tenfold.
All right.
Now, being how technology is advancing fast.
Yes.
I mean, do you really think it's going to be that long before we really start hitting space hard?
Before we start hitting what?
Hitting space. Be it the moon, Mars, you know. I mean, you're looking at technology pretty much doubling every 2 years. That's crazy.
I know. And
it's pace right now. So I almost have to laugh at people to say, yeah, we're going to be exploring different planets in the next 100 years. I'm like, 100 years? You better look in the next decade.
Well, yeah, I think here's the thing. There's some technological hurdles that we have to surpass in order to go to the nearest stars. First of all, we see on our horizons. Huh?
I'm talking about just our solar system, like going back to the moon, of course. Of course, the Mars project, the moons of Jupiter, you know. That stuff is not going to be that long if technology keeps going the way it is.
No, you're right.
The race is heating up with SpaceX and Blue Origin and NASA, and not to mention these other countries, new and thriving space companies. I really do think it's really going to start cranking up.
I don't disagree at all. And, privatizing space is probably one of the worst things to do because it's going to have the best result, but probably cause a lot of claim jumping on the moon. People are going to go to the moon, claim spots on the moon. People will then have to defend it, and it's going to get crazy as we advance and as getting back to the moon is more familiar to us.
Yeah, and people are going to want to stake their plots, if you know what I mean.
They do, and that's exactly right.
And I've said this before, and I'm pretty sure it was either you or Bill that was in agreement with me. So sorry if it's not you, but going to say the moon, I don't think we're really going to prosper venturing out into space until we're doing it as humanity and not countries. So once everybody's on board, like maybe different countries' space programs can do certain parts,
Yeah.
Concentrate on certain aspects of that. But until we all say, okay, this is a common goal for the world as humanity, let's do it. That's when we're really going to take off.
I don't disagree with that. That's probably true. But of course, everybody has to agree that there's a benefit to it. If you're hungry in Bangladesh, you could give two flying whatevers about going to the moon when you just want a sandwich.
Right.
So I get that. We have to conquer other problems first. And I think that
innovation, say to make water on the moon, just as an example.
That's right. Thanks, John, man.
That could be applied to, the middle of the desert somewhere down here.
Yeah. And for instance, the Mars 2020 lander is going to test a new system to make oxygen from the carbon dioxide atmosphere of Mars. Okay, because we have to be able to make oxygen if we're going to, habitate and have a habitable environment on Mars. We have to have oxygen, and we can't bring it with us. We have to make it while we're there. So the 2020 unmanned mission to Mars is going to test whether the system to make oxygen from CO2 could theoretically keep up with the needs of a burgeoning young colony on Mars. So oxygen generation is going to be a very important thing. Now you got to understand, Mars creates its own oxygen here and there. Through geological processes mostly, and also through atmospheric processes in conjunction with ultraviolet energy striking the molecules in the atmosphere of Mars. But it's an uncontrolled process, and it's a process that has continued like this for billions of years on Mars. To interfere with that and to terraform Mars, we have to find a way to stop the ultraviolet energy from getting into Mars' atmosphere and getting to the surface to sterilize the surface. And that's what when we in SkyTour Radio, Amanda and I have talked about this. It's her favorite thing. She calls it the Mars blanket. It's actually a magnetic dipole that is a north and south magnet located at Lagrange point 1, which is between Mars and the Sun. From Mars, away from Mars, very close to Mars, but far away from Mars enough so that it's a little parking spot in space. And so you put this magnetic dipole there, as long as it's powerful enough to generate a big enough magnetic field, then what will happen is, as the solar wind from our sun reaches it, it's going to be trapped by this magnetic field that's generated there. And if it's a big enough magnetic field, then the solar wind will push the magnetic field back over Mars. And literally, it'll become a shield for Mars. Okay, and that will then allow natural processes on Mars to continue without breaking down. So, when oxygen is generated inside Mars during geologic processes, it can get into the atmosphere and remain. When water vapor, sublimates and goes up into the atmosphere of Mars, it won't be broken apart into hydrogen and oxygen. And the oxygen won't go down into the crust and bind with iron compounds and rust more things. Like that's why Mars is red. It'll actually stay in the atmosphere. So maybe that will generate a water cycle. You must have done well on that stream, man. What are you doing?
Not bad.
No, thanks, man. Very cool. So Mars then having a blanket will terraform itself. It will end up having a beautiful second place to go. Now, Mars is cold right now. Well, that is because it's farther from the sun. But it's also because it doesn't have a thick enough atmosphere to actually generate a greenhouse effect to warm the planet. Mars has mostly carbon dioxide, but it's very thin. It's a fraction of 1% of our atmosphere. So clearly, it needs a lot more mass. But if the sun breaking down the molecules and causing them to go away on this ongoing basis, if we can stop that with our magnetic blanket, we don't even have to even touch Mars. All we have to do is shield it, from a distance with a large magnetic field. If we do that, then Mars will be protected. It'll build up its atmosphere. And in fairly short order, in maybe 7 to 8 years, we'll see a noticeable difference at Mars. It certainly won't be livable or habitable in 7 or 8 years. but we'll see that the atmosphere is building up on Mars.
You know what space agency would be perfect for that job, for the artificial magnetic field? India. They're already studying Earth's magnetic field, you know, and the magnetic field research. You know, they're really into that. So if anybody were to do it, that'd be a great thing for them to take on as their like first major, you know, problem solving in space. You know, go India.
Yeah, and go Ted Bronson. You know, he's keeping up with the Joneses, he says. Thank you, man. You know, I got to tell you, India has already got a probe around Mars, all right, and they have a burgeoning space program that's actually been very successful so far. So they might be a perfect nation to bankroll with the Mars Magnetic Field Project. Yeah. You know, and it's on the docket at NASA. They really think it's a very possible project. They've actually forecast the time span it would take to terraform Mars to become habitable. And now it's a few hundred years, but think about it. Mars has been in the state it's in for billions of years.
Yeah.
And if we can do this with Mars, well, guess what? Mars becomes relatively habitable.
Well, as soon as that's out there working,
in a fraction,
the change begins.
Yeah, it happens in a fraction of a blink of an eye, as far as the universe is concerned. You know.
Yeah.
Yeah, it's so cool.
You know, you almost just what do they say? Get the ball rolling.
Yeah, yeah. And by the way, I just want to mention here, this is Hubble's Variable Nebula that we're looking at here. Again, taken here. Now, why do we say Variable Nebula? There's a dark nebula here that you can't see. And inside this dark nebula is a star that's causing this to be illuminated. This is not one of those H2 regions. It's not a nebula that's made by exciting atoms. It's actually just a reflection nebula. It's a nebula. The dust in here is reflecting the light from a star that's inside this cocoon of black mass here that you cannot see into. Many people thought it was this star that's causing it. No, it's not. This star is not near it. Okay, so it's really something inside here. Oh my God! Seriously, Raymond?
Yeah, seriously.
What the heck?
Don't break yourself, bud.
Wow. I mean, looking for the dark. He's looking for the reddest color.
He's trying to up me. That's what he's trying to do.
I just, yeah. You know,
oh, he got me. I'm tapping.
That's it. You have to tap out, man.
Tapping out.
Raymond, you're the man. You are the man. Thank you, my friend. You know, wow. That's gonna be up there for quite a while. I don't think that. I'm just amazed. This is crazy. It's beautiful. And you guys stunned me. I got to tell you, you guys stunned me with this. You know, I know people want to hear about the science. I know they want to know. I know they believe in extraterrestrial life as I do, and they'd like to understand the science of where extraterrestrial life can come from. I get it. So that's what this is about. That's why the streams. That's why SkyTour LiveStream. I want to put a scientific face on the understandings that people have, but that sometimes are met with derision by the media, you know. And I step out there. I'm not afraid to put my foot out there and say, okay, look, if you want to deride anybody, deride me. Okay, you want to make fun of someone, make fun of me. I have a very thick skin.
Don't they?
What's that?
You know, we have the name P&K Science, of course, formerly P&K Space Imaging, and you start talking about UFOs, it does make a lot of science people mad, but, you know, the numbers don't lie.
No, but see, if you talk about it in terms of, and this is why, you know, I think that's the reason that I looked at my LinkedIn requests I told you about, and Neil deGrasse Tyson had sent me a LinkedIn request. Now, why would he do that if I was a UFO nut? I think he sees that I'm probably someone that's actually level-headed and just using science to kind of interpret a little bit and step out on a limb and say, well, look, let's look at the future here. We see a way off the planet. We see a way to go interstellar in a few hundred years, perhaps, say out a few tens of light years. And we're only 5,000 years into our written history, going back to Sumeria, when the cuneiform tablet language was first invented, kind of the real first time we actually had a language, so to speak, as a human species. And from 5,000 years to today, we already see several ways to go interstellar, some far better than others. So that's a blink in the cosmic eye. So You know, where will we be in 10,000 years? Wow, you know, where will we be in 50,000 years?
Not only that, but you figure the three of us, P and K, of course, Bill and yourself, you know, we're looking for that sign, that proof, either that we're being visited or that they're here, quote unquote, through the scientific means.
Yeah.
And that's what's missing. We're not, excuse the language, going to blow smoke up your ass and you know, tell you every little thing that's moving in space.
Now we're in 18.
Fine, don't worry about it. Actually, I was reading on the thing on YouTube. It's just don't curse in your first 3 minutes. After that, you're fine.
Oh no, yeah. So after 3 minutes, you can say Carlin's 7 words you can never say. No, I'll never do that.
You're a lot better for cursing if you don't have any cursing in the title or in the first 3 minutes of the video.
Yeah.
I asked our YouTube rep about that.
All right.
But yeah. And some things just need to be plainly put, you know.
Yeah.
We're not going to sit there and call everything. I mean, it has to go through the scientific process. As much as we want it to be something, as much as we think it may be something, it has to be proven. And that's the hard part. That's what, you know, Mark's doing the work with the UFOTOG, which is now
Aerial Anomaly Detection System. I talked to Doug the other day about it, and he's on board with the name because we had to change it because when you have, and this is why, see, when you have UFO in the title, don't expect anybody from a university to come funding you. Don't expect
much stigma wrapped around
right, because of the stupidity. But you know what? But if you talk about it as in terms of we're looking for extraterrestrial life, oh, those words okay. Those words are okay. See, but you say UFO, and now the guy with buck teeth and the tinfoil hat has to come out.
Yeah.
You know, and I don't understand that. You know, well, I do. I mean, I understand that culturally, this is what it was made into. You know. Yeah.
And as I mean, before, it was almost like scientists, like it was an automatic, like no, you know, it's almost like they had like bulletin points, you know, or bullet points where they had to say, you know, anybody ever asked about, you know, UFOs or aliens, it's an automatic no.
That's right.
Because you can get ostracized from your scientific community for that. Yeah. But I guarantee you, if you took a poll these days just of scientists, say astronomers or, you know, whatever, I guarantee you it's going to lean towards the yes, aliens do exist. It may not be whether they're visiting here, but I can almost guarantee that the answers from most of them is going to be yes, aliens exist and they're out there somewhere.
Well, we actually know that that is a yes, actually. You know, Avi Loeb, who's a Harvard astronomer, he was on the ABC special with Doug and I. Avi Loeb is the guy that talked about Oumuamua possibly being a probe from an alien civilization. Now, he wasn't saying it was. Right, and he was been misquoted as saying it was, and the media, you know, sort of half-heartedly tried to make this tremendously wonderful guy.
Is that the one that security team was like, this astronomer is saying Oumuamua was an alien craft? And
yeah.
This colleagues think.
Yeah.
Like, give it a break.
Yeah, no, see, Avi was saying this, okay? He was saying that we don't know what it was. There was nothing like it. It's really... you know, we suspect there have been other interstellar asteroids coming through, but this was the first one we actually caught. Okay, so because it was interstellar, because it was really oddly shaped, it was 10 times longer than it was wide, basically. You know, that's really odd. There's no spindle asteroids in our solar system, and what would have caused an asteroid to form like that? That's what was racking the brain of you know, astronomers all over the place. So when Avi Loeb was looking at this, he figured rightly, well, maybe it wasn't an asteroid. We didn't get a picture of this, you know. There's all kinds of photos of it out there. Not photos, but artist renderings of this thing. But no, we never got a picture of it. Mm-hmm. We only got a picture of it as it was speeding through the solar system, and it wasn't a picture at all. It was actually just data. And basically from the data, they determined that there was an object 10 times longer than it is wide. That's as far as we got, you know. And they figured the surface, they said the surface was like a ruddy brown red color. That's consistent with lots of radiation striking like a rocky surface. So they said, oh, maybe it's got to be an asteroid.
And of course, the shape threw a lot of people off, which is why it got as popular as it did.
Exactly.
That's why, I mean, you got this giant Mr. Hanky, you know, flying through the solar system at enormous speeds.
Yes.
You know, and then it's gone before you know it.
Yeah, it was moving.
The conspiracy is there.
Yeah, moving on very, very fast. Yeah, exactly. So yeah, so the bottom line is that the folks that want to believe it was something else, I get it. But the fact is, we don't know what it was. So Avi Loeb could be right. You know, he could be right. Maybe it was. It could have been.
Sure.
And there's nothing to say he was wrong about that. You know. We know one thing though. We know one thing though, that if there was an alien civilization, it didn't come from this pair of stars. Okay, this is the summertime pair of stars called Alberio. Okay, it's a double star, beautiful, and you know the stars are separated by something like 5,000 astronomical units. This is a K-type orange star, and this is a B8, hot blue star, and they're orbiting each other. And
Matt has a question real quick in the chat. So how fast was the Oumuamua going? You remember? I know it was super fast.
Well, I know that on the way out it was traveling like 86,000 kilometers per hour, I believe it was. On the way in, it was like 165,000, I believe. But, you know, my numbers are going to be slightly off. But, yeah, you know, and as it passed the sun, of course, it was accelerating as it got here. Then as it went out, the sun was pulling back on it, so it slowed it down a little bit. But it was coming from deep space, and it came in from above the plane of our solar system. It didn't come from the asteroid belt. It came from way up above, you know, basically on top of the spinning record, if the spinning record is our solar system. And that was, yeah, Charles has it there. It was like, yeah, I think that's the average speed, 95,000 kilometers per hour.
You see, now they're thinking that the Milky Way is actually weirdly shaped.
Yeah, it has a warped disk, possibly. Yeah. And that means that could be because of interactions with the dwarf galaxies, the Magellanic Clouds, which is really fascinating. Now, we've never seen these up here in the Northern Hemisphere, guys. But for James, our buddy down under, James Dugan, he's seen the Magellanic Clouds, of course, named for Ferdinand Magellan. And the Magellanic Clouds are dwarf galaxies. There's a large and small, and there are two dwarf galaxies. They don't have much structure, but they actually have been attributed to being like satellite companion galaxies to our own. Now they're thinking maybe they're not actually bound to us at all, and they're doing their own thing, heading out or away or whatever. And it's possible that that our galaxy is a little bit warped, possibly because of having in the past collided with those dwarf galaxies, or one of them at least. So it's pretty interesting, and that's a really a fascinating read when you look at that paper, you know. But you know, so anyway,
should go down to James, hang out with him for a couple weeks, do some telescoping down under.
You kidding me? Love to. Oh yeah, I want to get to I want to get on there. I want to get to Australia. Now, those of you in the chat, you probably recognize this. We took this picture last summer, July 19th, I believe. This is the Dumbbell Nebula, and right in the middle here, you can see this little tiny star. That star is a white dwarf, and it's very hot and sending off an immense amount of ultraviolet radiation. Ultraviolet radiation has excited the oxygen atoms that are in this nebula. What is this nebula? I'll tell you in a minute.
Hello, Eric.
Eric's here.
This to Road Warrior, right?
Yeah, there he is. Hey, Eric.
See, I did remember.
Yeah, you're right.
Get him and Jade mixed up.
Well, you know, Eric and I have to talk, actually. He's got a case, a UFO case that we have to talk about. So I'm glad he's here, because I'm going to try and get to that. But
anybody that doesn't know, American Road Warrior is the state director for Massachusetts, is it?
Yes, it is.
For MUFON.
Yep, yeah, he's a good guy. He'll be at Bill's for Pine Bush, I expect. So really pleased that he'll be around. He's very diligent, very good, you know, about what he does, you know. And we're trying to orchestrate getting together for a trip to the observatory for his Massachusetts group. Have him come here. And unfortunately, it wasn't a good night, and the weather was bad, so I would really hate to see people driving around and getting hurt, you know. So we called it grudgingly, but it was probably a good thing we did. You know, but
don't reschedule.
Yeah, but he'll be back. He'll come back with his group.
Yep.
You know. So anyway, this is the remnant of a dying star, and the dying star is dead. It's here. That's a white dwarf, And because of its ultraviolet output, it's causing the oxygen atoms to glow and some of the hydrogen atoms to glow. And you can see this is just a tremendously large envelope. It's about a light year across. And so it's also one of the closer planetary nebulae to us. It's really kind of hard to determine their distance. But they tend to be somewhere in the order of about a light year across. Okay? And so this, you can see the knots and convolutions. There's a beautiful Hubble photograph from this area of the Dumbbell Nebula. This is also known as Messier 27. And, it's just so rich and complete with so much detail. It's like, I want that telescope now.
Did you ever find that Andromeda one that you took?
Yes, I know that I did, actually. I found that Andromeda one.
Last time I was on, we were trying to find it.
I know. I know that it was here. I actually, I have it. Oh, should I go look for it?
I can honestly say that's my favorite picture that you've taken so far.
Yeah.
Personally, that's my favorite picture.
I'm going to try and find it. I'm going to try and find it. I know that it's here. I know that I actually, I have it. I looked for it. I found it and then said, that's good. I have to show that to Keith. And then,
well, you sent it to me and then I can't find it. It's somewhere on the computer.
Yeah, I know.
I'm really good at naming stuff so I can find it later.
Yeah, and I'm so good at naming stuff that I ended up not being able to find it later. I know, lucky me. And now that you asked about it again, and I knew you were going to ask, and I just didn't do it,
Well, I know we talked about it so much last time.
Yeah.
I figured some people would want to see it because it's an amazing photograph for a 12-inch scope. An amazing shot of Andromeda.
Yeah.
Just in all its glory.
Oh yeah, beautiful. Yeah, and I'm trying to find it, even now as we speak, and I'm not having much luck. But I know that it's here. I know. I'm trying to remember where it was actually located, because I set it aside. Of course. Yeah. Wouldn't I though?
That happened.
Yeah. Fine now, see? I'm the frog, see? Nobody can stop me. I'm the frog.
I know I don't remember what I called it.
Yeah. Well, I'll be looking for it. I'll find it. There's other photos of the Andromeda Galaxy, though, that I have. This one, though, is not the Andromeda Galaxy. This is the Ring Nebula, Messier 57. In the constellation Lyra, and when you look in this one, you can also see this really tiny star, white dwarf, exciting the oxygen to glow, along with some of the hydrogen gas as well. So it's really the same kind of thing. It just, and both of those are in the summer sky. This is another one of those, and this is called the Little Dumbbell. All right, and it's just such a beautiful. Messier 76 for those that want to know. And you'll notice the same thing, okay? On the edge is a little bit red, and then you have the oxygen here that's glowing. Very interesting now, the way that looks. And those are classic. Now, here's the interesting thing. These types of nebulae, the planetary nebulae, so named because they look like planets in the telescope, were set up to be the remnants of dying stars where white dwarfs were in the center. Well, if you recall, a little earlier, we went through and talked about these guys, the Wolf-Rayet stars that actually cause these types of things. This is a Wolf-Rayet star that made that, okay? A Wolf-Rayet star made the Bubble Nebula, too. But could this not be a planetary nebula if it had some oxygen there? Well, yeah. Okay, typically, the Wolf-Rayet stars don't have any hydrogen to actually expel. So in the Dumbbell Nebula, we don't see a whole lot of red from hydrogen, do we? We just see oxygen. So maybe we're going to be changing the definition. Astronomy is evolving, folks. We might be thinking that instead of a white dwarf, maybe this is actually a Wolf-Rayet star. One of those hot, very, very, very energetic stars. And so the line is blurring between these types of stars. whether the planetary nebulae are always white dwarfs in the middle. But that's
just sent you a file on the Skype chat. Is that the photo?
Oh, he's got to. Okay,
I think it might be because it was saved as a Skype thing, so that means it came across on Skype. So I'm thinking that might be the one you sent me. You'll know it as soon as you see it.
That's the one.
There you go.
That's the one.
You will get to see it, people.
Yeah, maybe so, huh?
I'm telling you, it's my favorite one you've done. I mean, the conditions had to be perfect for that.
Yeah, they were.
And it was just that little window that you had that night. What was it, like 15 or 20 minutes where it just turned out perfect?
Actually, the whole night was beautiful. And it's just that the 15 or 20 minutes I took to take that picture, which you're all about to see, is really... I just couldn't say no. It was high in the sky. We actually took this with the 5-inch refractor in the observatory. This was the one that was mounted on the telescope. The regular telescope only shows the center. I'll show it to you in a second as I...
Well, I'm hoping you still have the raw image, like the large file size, because I really want to get that as a print for when I get the new studio done.
Yeah, I didn't get rid of anything.
I want to. I mean, I'm talking about a big print. I want to get like a, you know.
Well, it's only so hard, so large it can go.
Oh, I know, and I'm going to take it to the max.
And that's what I expected. All right, here, let me just
centerpiece on the wall, you know.
Sure. Okay, let me drop this in here. I'm going to bring it into my...
Wait till you guys see this.
It's a beautiful shot, yeah. Very, very happy about it, too. I was very pleased with it.
I've never seen Andromeda with that much detail, especially from a 12-inch scope at that.
Well, ours is a 10-inch.
Oh, yeah, that's right.
And this was a 5-inch that took this picture.
It's crazy.
Yeah. The 10-inch was just guiding the 5 because it was on the same mount with the 10.
Mm.
Yep. Well, that's what we do. We always try to we always try to outdo ourselves, right?
Stellar.
Exactly. All right, so let's go through this now and see if I can just grab it and bring it up. So this is M76, the little tiny planetary nebula, but now Keith would like me to show you something else, and I know what that is. He wants me to show you. He wants me to show you this picture right here.
Look at that.
This is the Andromeda Galaxy. Yeah, this is 2 million light years away. Actually in fairly correct colors, and you can actually see the satellite galaxies to Andromeda here. Dark lanes within Andromeda, lots of stars. You can see here, you can see this right here. Actually, zoom in a little more.
Make sure you're on 1080p too, guys.
Yeah. This is a large, probably an OB association. That's O stars and B stars. Very hot young stars in clusters. There's more down here. You know, it's just amazing. There's a lot of
that is another
detail.
Galaxy.
Yeah, and it's heading for us too, by the way. About 3 billion years or so, 2 to 3 billion years, it's gonna come through here.
The core is so bright.
Yeah, well, that's actually a problem. We don't want it to be that bright, but
no, but man,
it's okay.
Stellar image. I mean, you got the spiral arms. You know, you got the definition between them. It's just,
yeah.
I mean, the conditions had to be perfect for that, and you nailed it.
Oh yeah, this was beautiful. I mean, we really had it was a good night, no doubt.
And I am really getting that. You know, that will be a centerpiece on my wall in the studio.
Well, for sure. We'd be showing live views right now, folks, but unfortunately, with the fact that we've been clouded out, that's not going to help us. But I figure we can show you these things, and we'll go back to live if it's clear. But yeah, there it is. That's beautiful. And the center of the galaxy has older stars. They're more metal low, meaning there's less elements in the stars. Like hydrogen and helium is pretty much predominant in those stars. Out here, these stars are made with other elements that formed in other stars and were blown back into the interstellar medium when they went supernova, and so they're more metal rich. Metal, what's metal? Metal is anything other than hydrogen and helium to astronomers. So we're a little weird, but we basically say that.
How far away is Andromeda, light year wise?
It's about 2 million light years.
2 million light years. So that sure was Andromeda 2 million years ago.
Yeah. And if you think about it, yeah, that's only 2 million light years corresponds to 2 million years ago. Yeah. And if you look at the Earth, say what was going on 2 million years ago here on the Earth, and then you say, wow, well, Australopithecus afarensis, Lucy, wandered out of the African subcontinent. Was it
I was going to say Tyrannosaurus Rex was trying to scratch his armpits.
That's funny.
But
it was about 4 billion years ago when Lucy was around. So 2 million years ago was like, we were well underway. The hominids and the non-human species Homo erectus was still to come. It wasn't even out, and evolved yet. So there's a lot of that going on. The species were changing all over the place back when Andromeda looked like this. So yeah, I mean, it's just incredible, and I love this knotty texture here. And if we can actually zoom in on that. Okay, see this knotty texture here in the galaxy.
Yeah,
it's just beautiful the way that that circles around.
Yeah, and you can tell, see how it's circling in towards the center there.
Yeah.
Of the core. That's just amazing.
Yeah, and if we actually, there's other things to do. We can actually go back, take the original data we used to make this image, take new pictures that underexpose the core, and combine those images with the underexposed core with these images where the core has been removed.
Good.
And we'll get a combo photo to actually show the knotty stuff that's in here too, because there's actually, where this curves around, there's actually more going on in here that you can't see. And that's something we could do. And
that is my favorite photo.
Well, I'm really glad. I'm glad you like this photo. When I saw it, I think that when I did this live with folks, and I think when I saw this picture, I think I actually gasped.
Yeah,
You remember that?
Because I went back because I couldn't believe what I was seeing, and you did a little. Oh.
I think I went, oh, I couldn't believe what I was looking at.
Yeah,
it was just so stunning, and right then and there, I decided I'm going to take a whole bunch of these to stack. And this came out beautiful, yeah. But this is SkyTour LiveStream. This is what we do.
The weight of space.
Yeah, and this is about the right colors too. The Andromeda Galaxy has these colors in it, and I took a long time to get these colors right. The center of a galaxy is always going to be a little yellower. Stars are older, less metal rich, and the stars out here are bluer because they're younger, because star formation occurs mostly in the spiral arms of a galaxy, because that's where all this action is. That's where things are going on. That's where the stellar nurseries are located.
I've seen people with these giant optical telescopes that didn't get Andromeda that good.
Oh well, I think
that's just good stacking. It was just
I think it's a matter of just diligence and making sure that you ditch all the photos. I took probably 40 or more photos of the galaxy, about 20 seconds each, 25 seconds each, and then I probably threw away a good number of them, because some of them had slight trailing, and you're tempted to keep them in to get the best image. But if you don't throw away those bad ones, then every little detail gets blurred just a little bit.
Yeah,
and that's just no good.
And this was 40 some odd.
I think it was more than that. I think it was like 48, if I remember counting them. I didn't get to 50, but I remember, and that's actually about the number that you would go to typically, And I think what was the actual ISO on this one? I think it might have been 25,600, or not. Maybe it was actually 12,800. Because we don't need a whole lot with the Andromeda Galaxy. But these, here's what I like about this particular photo. You can see these secondary dust lanes, the primary dust lanes here, okay? And it's just really, there's so much detail there, Now I admit, okay, I wrote a little program within Photoshop to bring out more of these details, and it's not a program that alters the data. It actually just refines what we see. It actually makes it look better. It takes the existing data, in other words, and it makes it look better. It doesn't actually, alter the data. Okay, it just kind of removes stuff that's stopping you from seeing the good data. And that took a while to do, but I figured it out.
Yeah, it's great. I don't care what you did. Looks good. My fave.
Yeah, and James Dugan's right. I only do 30-second lights, in other words, data frames, at the most. And that's only because beyond 30 seconds, there's really no telescope that's going to stay perfectly guiding on the stars beyond 30 seconds, especially at some of the magnifications we're using. So I tend to just go to 30 seconds max because I've tuned the telescope to be as good as it can be, for that. Oh, SF, thank you. That's so cool. That's very cool. Thanks, man. So I'm really convinced that the best results come to those who are really patient. So this is patience here. This was patience. Years of seeing the Andromeda Galaxy in a telescope, and finally I could take some pictures of it that were really, really incredible. I'm glad you like it too.
Yeah, just do me a favor and search sometime to see if
I'll find the
file.
I will. There's a TIFF out there that I have.
Yeah. Now we're talking like as large as you can get it. That way I can find out how large I can actually make it. Because if I have to go poster and just put it in a frame, I will.
Okay. All right.
So.
Yeah. Now over in Cassiopeia, we have the Heart Nebula, which is here, and this is just beautiful. The Heart Nebula, we did this one on Valentine's Day to showcase Valentine's Day.
Look at that. Even Maddie says I'd love to have that on my wall. See? What are you doing, Mark? You can be printing these and selling them.
Well, I don't ask people to buy them. I just say, hey, go out and go to the SkyTour LiveStream on Facebook and download them and have at it. Go off to Kinko's or go off to your nearest Office Max or a place that actually has the photo reproductions and go for it, guys. Astronomy should be free. Shouldn't be something you have to pay for, right?
I was trying to find. I've seen a question from Charles somewhere, but now I can't find it.
Charles Smarr, otherwise known as Blue Orb. Here's the Horsehead Nebula.
But he's not Blue Orb on here. He's Charles.
Yeah, I know.
I'm trying to.
Here's the Horsehead. Now this.
Hubble did it. I'm not sure where. Oh, even Lars said something about it.
Okay.
I'll keep looking.
All right.
I saw it a while ago, and then I was like, oh, I got to remember to bring that up, and then totally forgot.
Yeah.
As you.
That's all right. This is a dark nebula. This is all dust in here. And the Horsehead, Hubble did a beautiful photograph of this. And it's just beautiful. And the Horsehead itself is really has so much detail in it, especially right around here. So this photo represents one of the best nights we had viewing the Horsehead. It's very faint. And it only shows up in silhouette against this hydrogen 2 emission nebula behind it. And this emission nebula is excited and made to glow by a star that's not quite in the picture over here, Sigma Orionis. And it really is beautiful.
That is a good question.
Yeah, it's just beautiful. And you can see a reflection nebula around this star over here.
Charles said, what is the difference in process of a formation between a dumbbell and a ring nebula?
Oh, well, that's actually a very good question. Planetary nebulae come in several flavors, Charles. The one like the ring nebula, originally we thought maybe it was an expanding sphere around the star. And when you look at it face on, you're looking through less gas, so you see through it. But on the edge, you're seeing through more gas, so it looks like a ring from all sides. But further analysis of the ring nebula in particular kind of indicates that the ring nebula is actually a barrel where we're actually kind of staring down into the barrel, which is really odd. the dumbbell is actually one that's called bipolar, literally. You know, not like people, but by nebulae. Nebulae can be bipolar, and that means that the nebula actually has a strange appearance where it actually has like poles, north and south. It has material coming out like at the north and south pole, but then on the east and west side, the equator of the nebula, so to speak, you see less stuff. And it's bipolar because it's happening at the two poles. Really interesting. And the dumbbell is one of those bipolar nebulae. If we just pop back to that for a second. If I pop back, let me just do that.
Yeah. Thanks again to SF.
Oh, yeah? Okay, so that's back to the beginning. And we are... and some of these, there it is. Okay, so this guy here, the dumbbell nebula, all right? Yes, thank you, SF. This guy here is bipolar. Why? Because it has a thrust of material that's coming out like this and like this, kind of like an hourglass, less on the sides here. And that represents an interesting way in which the star expelled its layers, all right? Now, maybe the north and south pole are here, and then north and south pole are here. And this is the equator on the sides. Maybe it's going out that way, all right? Or maybe through other processes, it's going out through the north and south poles because of energetic gas jets that are sending stuff out there. You know, and I think that's pretty cool, you know. So, you know, that said, we have an awful lot of planetary nebulae out there. We have a lot of incredible nebulae to look at.
Space is weird, man.
It is a weird place. There's no doubt. There's a lot going on there. And this
crazy stuff.
I'm actually going to I'm going to show you this too. This is Messier 33. This is the Triangulum galaxy, which is right near the Andromeda galaxy. And I've circled in this one. We did this one in SkyTour LiveStream, of course. And what I did was in this one, I actually circled a very large H2 region. That is a star formation region.
Raymond, if you keep going, you're going to have to claim Mark as a dependent on your taxes.
That's the way you're going to go, man. I swear. You know, it's crazy.
Yeah.
I love it. You know. So, but I thank you guys, man. This is wonderful. So this is a large region here that would be like the size of the Tarantula Nebula that we have here in our galaxy. Actually, the Magellanic Cloud. And so that's pretty neat. And you see over here, there's another H2 region. This is about the size of the Orion molecular cloud and nebulae. Another one over here. Over here, there are almost everywhere you look, you see H2 regions in this galaxy here and here. Everywhere I'm going, you see them right here. These are star-forming regions. You'll notice the core is a little more yellow, and the arms here, the arms are very clear. A lot of hot, bright stars, and the arms are knotty with, as in Knotty, knotty with a new star formation in here. And the arms are just beautiful. Now, this is a galaxy that's more of a what's known as an SC. That is, it's not a SO, which is very tightly wound spiral. It's not an SA, which is less but still tightly wound, or an SB. It's like an SC, where the arms are very open. This is beautiful. You can actually see the red color in this, and if we zoom in on that, you can actually see that very well. So that's a really interesting. I took some time processing this one too to make sure that it came out. I forget how many photos I took on this one. This had to be a lot of pictures as well. Yeah. But man, it was just beautiful. Nobody in their right mind would not know what this is. This is the Pleiades, of course. And the Pleiades are amazing because of what they show us. These are all hot B stars. All right, and I think I have another version of the Pleiades. This is a close-up, actually. But the
Pleiades.
The Pleiades, yes, the Seven Sisters. The Seven Sisters, Brian.
Sisters with 10 little stepsisters.
Exactly, and maybe 400 stepsisters. But see, if we look at the Pleiades, one of the things you notice is that there's this really interesting brushed-looking combed nebula here. And then there's one here, up here. Okay? This is Merope, and this is Maya, and this is the Maya Nebula here. This is Alcyone. And you see these stars, these are hot blue stars, and they're actually moving through space and happen to be going through this cloud of dust. They didn't cause this cloud of dust. They weren't born here. They were born elsewhere, and they're just migrating through as they're coming through the galaxy, going around the galaxy. Isn't that amazing?
Which one's moving? The stars or the cloud of dust?
All of them.
So they're moving in different directions?
Well, they're kind of
better than the other.
I'm not sure actually the actual they're called the proper motions. The proper motions of the stars versus the cloud itself. In this case, so I can't speak to that, but I would imagine that the stars and the dust are kind of going in roughly the same direction. They're going to be off from each other, maybe different velocities, but these stars just happen to be illuminating this dust as they're passing through. And this nebula here, that's up here, which you can't see too well there, but over here you can. This is the Maya Nebula that's up there. The Merope Nebula is down below here. Okay, but that's just beautiful.
There's a lot of mythology related to the Pleiades.
Yes, and a lot of cars. I mean, the Subaru has the Pleiades on the front.
Yep.
Yeah.
But if you ever get a chance to actually read up on the Pleiades stars, very interesting read. But it's one of those things that can be seen with the naked eye, even with moderate light pollution. At nighttime, you can still see that nice cluster of the sisters up there. Fairly good.
Oh yeah, you can certainly see the cluster. Okay, this is a little bit of a processed shot that I just did right now, just to kind of illustrate how much extra dust there is. Okay, and it is slanted toward the blue because of the stars.
I just scared the crap out of myself.
Why?
I took a drink and I swallowed it, and I guess it was amplified because I have the headphones on.
Oh.
I was like, what the heck was that?
You're funny.
No, it's stupid, but it scared the crap out of me.
It's
like, what the heck is melting behind me? Like, don't act like you all never done it before. I know you have.
That's funny.
Like earmuffs on or like completely quiet.
Yeah.
And all of a sudden you do something in your mouth and it's like really loud.
Yep. Yeah, I've done it. I can't say I haven't. No, you're right. So yeah, that's the Pleiades. And the stars again are very hot and blue, B-type stars. And we get the hottest are the O-types. And if Amanda was here, she'd tell you the O is the hottest, then B, A, F, G, which is us, K, and M. And it's the M stars, which are the most prevalent star in the entire galaxy, probably in the universe. There's more M stars than any other kind, but you can't see a single one without a telescope. So it's just amazing. And I'm going to put together another slide program at some point here and to actually illustrate how we can see these M stars and look at the different types.
Did it really cloud up there pretty bad? Yeah,
we got clouds here now. Yeah. This is the Omega Nebula. Okay, Messier 17. And it's just a gorgeous photo. And it's right near the Eagle Nebula, all right, which I'll show you, I think, shortly.
Do you want to explain to people that might not know why they have M designations or the Messier designations to them?
Yeah, Charles Messier in the 16 and 1700s, he was mostly 1600s. He was out to find comets, and so he put together a catalog of things that aren't comets. And those things that weren't comets turned out to be what he called Messier catalog numbers. And for instance, this is Messier 42. Okay, this is Messier 17.
How long ago was that?
He did it in like the late 1600s.
And look at that, 2019, we're still using it.
Yeah, we are, because it's actually a wonderful catalog. And then we have contests. Amanda wants to do a Messier marathon where we actually try to see all the Messier objects, through all 103 or so in one night. But you have to like stay up all night, you know. And she's all happy about doing that, and I'm like, oh man.
You know you need your beauty sleep.
Oh no, I've done this before though. I've done these Mesher marathons, especially when I've gone to these, these outdoor astronomy festivals. You're up all night for like 2 days, you know. And then at the end of it, you drive home. It's like, whoa. I did that one time and ended up in the hospital because I had taken no dose to try and stay awake. And I had never taken that before. And a friend of mine said, oh, I usually take 2 of those. Well, they're caffeine pills.
Yeah.
You know, I mean, okay, so drinking a Coke or something helps you stay awake. I get it. but 2 caffeine pills was like 12 Cokes.
Mm-hmm.
And so I overdosed on caffeine without realizing it. And as I was driving in my truck with $4,000 worth of equipment in the back, my hands just fell off the wheel and I had no control of my hands anymore. And I couldn't move. And I started hearing this weird buzzing in my head. And I thought it was like an alarm from the car or something. And I realized I'm drifting off the highway, and I almost didn't care. I'm thinking, wait, why am I going off the highway?
Astronomers all doped up on caffeine.
I was. It was the weirdest thing. And then next thing you know is I ended up grabbing the wheel again. And I quickly pulled over and got on the radio and talked to my friend who was with me and said, Jay, I don't know what's going on. He says, well, maybe you should eat something. So I did. I ate a ham sandwich at 4 a.m. Okay, driving home, you know. And I still had 3 hours to go, you know, to drive. And Eric says, yeah, he did the same thing. So, you know, what happened was I felt a little better, you know, and got the cold air, and I was like, all right, I'm feeling better. Started driving home. It happened again. Next thing I know, I'm seeing lights, the white lights of the ceiling going by. I'm on a stretcher. I said, whoa, what happened here? I have no idea what happened. And then it was lights out. And next thing I knew, I woke up again. I was in a trauma room. And I'm looking at myself, and my head is spinning. I'm dizzy. You know, no headache. Okay. But I look down. All my limbs are there, and my hands work, but I can't open my left hand. It's a fist, and it's hurting. It's so tightly clenched. And the nurse came in, and she goes, well, welcome back to the living, in the world of the living. I said, what? What do you mean? She goes, now I left at 4 a.m. I was actually got to the hospital by like 4:30 a.m, as it turned out. It was 5 p.m. And I woke up, and the nurse says, yeah, it's 5 o'clock in the afternoon. You've been asleep all day. I went, what happened? She goes, well, I'll show you. And she reaches into my pants that they had taken off because they didn't know what was wrong with me. And she pulled out the package of no dose. She said, did you take these? I said, yes, I did. My friend Jay said that they'll help keep me awake because we were driving a long distance. She goes, oh, I know. She goes, you're not the first one to make the mistake. I said, what'd I do? She goes, you OD'd on caffeine. I said, wow. It shuts you down.
Yeah.
I didn't realize that.
Caffeine in high doses isn't no joke, man.
Yeah, well, I discovered that, you know. So anyway, I said, I can't open my left hand. And she goes, you're not going to believe this. She goes, but we've been trying to get you to open your hand all day, but you just won't open it. I said, why? What's going on? I can't open it. And she said, well, I think it's and she said it like this. She goes, I think that your friend Jay, hypnotized you into not opening that hand. I go, he doesn't know how to do that stuff. I mean, he's just an astronomer like me. She goes, no, he basically said, he put $20 in your hand and said, don't open it until you're awake. And for some reason, that struck you as a post-hypnotic suggestion, and you haven't opened your hand in 6 hours. No, not 6 hours, more than that. All day long, 10 hours or more. And I'm sitting there, and my arm is aching, And finally, I just focused on my hand, and I started to open it. And sure enough, there was actually a $20 bill in there that Jay put in there. And he did that so I could get gas in case I needed it. It was really, really nice of him, So
he just bounced. Huh? He was like, he's overdosing on caffeine. Here's $20. I'm out.
Yeah, right. Well, he couldn't wait around. And then I found out from the nurse. I said, how did I get here? Did I crash? Oh, no. She goes, I can tell you what happened. And she went and got the notes from the guys that brought me in. She said, it seems that you actually drove yourself here. I went, what? I don't remember any of that. She goes, yeah, your short-term memory's been just crippled by this caffeine. Wow. So I drove myself there. Yeah, you drove yourself here and you collapsed in the door of the emergency room, and we had to take you in. It's like, holy cow. I had no idea, you know, but I knew enough to drive there apparently, and Jay kind of led the way. And Jay, when I talked to him, he said that I had followed him. So I was like, wow. And none of that. I still don't remember any of that. Isn't that crazy?
So, when hanging out with Mark, no caffeine.
Yeah, well, I don't use it. I'm not using caffeine. Actually, okay.
You're not a coffee person either, are you?
No, I'm not. I don't drink coffee, but I do drink like a Coke here and there, you know. You know, but I don't depend on it.
I never was a coffee person until like I'm gonna say in the last year or so. I've been drinking it a little bit more, but not like majorly. You know.
Yeah.
But I'm not a soda person at all either. Like soda or beer, I can't say. Like I think it's just because of the carbonation. You know, I just something about it I don't like.
Melanie has a great idea. She has a little process. She decaffeinated several years ago after being addicted for years, and oh, thanks SF. Oh, you did it too, SF. Oh man, yeah, and isn't it great? Nah, thank you so much for that. Eric, I saw that you crashed at a Robert Plant concert on No Dose, and then Melanie was talking about she would drink a Coke to actually get to sleep. I think
it's kind of crazy, like especially the people that are used to having it all the time. If they like quit,
yeah,
you know, like months later, it actually have the opposite effect.
Wow. Yeah, I think that's kind of crazy, but I mean, there's no doubt it happens. You know, so this was the Orion Nebula, by the way, over here, and obviously, yeah, and then this was the Running Man Nebula just north of it. It's really beautiful. And we took some beautiful photos of the Running Man. I don't know if they're in this list, but this is the Rosette Nebula. Okay, another star-forming region. You can see these beautiful dark lanes. This was another night where this is actually a combination of 4 photos that I put together. This is an upper quadrant, a lower quadrant, the left side, and then the upper left side. And I put all 4 of those together, made sure that within Photoshop, they were all what are called properly flat fielded, so that they're all the same brightness all the way across at the very back, you know, in the darkness, so that when they were put together, you couldn't tell where it got a little darker and then a little lighter again. I mean, you didn't see the seams, in other words. Just beautiful. And there's a bright cluster in the middle of the Rosette Nebula. Rosette's funny because it almost looks 3D when you look at it, doesn't it? It almost looks like you're looking at it in 3D already.
That kind of square around the center part there kind of almost looks like a cube.
Yeah, that's true. Like this, yeah. There's a weird thing here, but that's actually an optical effect with your eye, probably brought about by this bar up here.
Aerodalia.
Raymond, you got a green. That's awesome, man. Ray, I love this. They're having so much fun, and I'm having fun doing this. Here's the Running Man Nebula now. This is probably one of the better shots we've taken with the SkyTour LiveStream. It's got a little bit of an issue. If you notice the stars here, they've got a little issue. That's something that I've since corrected a little bit. It's still happening, unfortunately. But the beautiful Running Man is a reflection nebula. But notice this right here. Okay, look at this little area right here. This is an area where there's this very subtle dark dust down here, and then it gets really thick here, and you can actually see the wisps coming off of the side here. Isn't that great? This is beautiful, and this was very much so a relatively short exposure. It was only 30 seconds, but it was a stack of a bunch of 30-second shots. Actually 25 seconds, sorry. But that's beautiful, and the colors have been set up to be exact what they're supposed to be. It's just beautiful. Called the Running Man because obviously this darker dust lanes in here look like a running man, which is kind of cool. Gotta love it, you know.
The colors of our universe.
Yeah, and that's a reflection nebula, you know. So let me go see if there's a couple more that I want to show that should be in the list. I know they're here. I just want to find them. Where are they? Oh, well, naturally. Okay, let's see. I'm looking, hang on.
Are you chewing gum or something?
No, I'm not. Here we go. This is what I wanted to show you.
It might be the keys on the keyboard.
I'm not using the keys. I don't know what it is. This is an interesting photo. Okay, this is Messier 16. This is the Eagle Nebula. When I saw this outside this particular night, now the Eagle Nebula is very far south from me. Not very far, but it's actually far enough south so that I would not expect this type of photo. This is, you know, is that you? Keith? Are you there? Keith, are you there? Don't know where he went. All right, hang on, folks. Let me just go see if he's here. All right, I don't see him anywhere. Let me see if I can get him back. I shall try to call him. Not sure what happened. Thank you, Skype. I guess not. Alrighty. Well, no worries. We'll continue. I'm sure he'll get back to us if he can. So anyway, what I was talking about was this particular nebula. Is the beautiful Eagle Nebula. Now, you might have seen the Eagle Nebula before when for instance, when the Hubble took these beautiful photos of the pillars of creation, which is this section of the nebula right here. These pillars are stunning, and you can actually see little appendages, little things coming off. You can see areas where the stars actually have these trails of nebula behind them, all caused by stellar winds that are occurring inside this stellar nursery. These pillars right here, as I said, the Hubble Space Telescope took that picture, a very famous picture called the Pillars of Creation. Well, these are they, right here, and they are stunning, really stunning, you know. And I have to say, I have to go out here, Laura, thank you so much. I won't put that in my left hand, Laura, I promise. Thank you guys, thank you so much. And SF, you know what? It's like you're going to be amounting to more than other people by the little. He's giving $2 donations and going on, but it's like many $2 donations. It's like, wow. I appreciate you guys very much. This is incredible. But I'm having a good time, and you know, why let a cloudy night ruin our time, right? So looking here, okay, this area right here is another amazing area. This dark nebula right here. This is an area, again, a dark molecular cloud material, dust, and molecules of hydrogen gas, H2, bonded together. Molecular clouds are the start of star formation and planetary formation. You know, and you can see, actually, when you look at this nebula, you can actually see in the Eagle, you can actually see areas where it's very bright here because starlight is hitting this and ionizing this, and then in the shadow there's dust and stuff in here that darken it a little bit on the lee side. Same here, you can see the edges are very, very bright and then darker down here. What an incredible what an incredible place this is. I'm glad we're not there though, because if we were there we wouldn't survive. This is very, very highly ultraviolet bathed area here, because that ultraviolet energy is exciting the hydrogen gas here to glow in this red color. Okay, that's something, like I told you, that's ionization and recombination is the process. You know, the electrons jump off. There's only one electron on the hydrogen atom. It jumps off the atom, and as it collides with other objects outside the atom, it then falls back into the atom or another atom, And as it does, it drops into a particular energy state, and that energy state is from anything above energy state 4 or so down to energy state 2. And there's a bunch of discrete energy states in atoms, which incidentally is why it's called quantum mechanics, because the energy states are these discrete quantums, these discrete quanta, 1 through basically infinity for the different atoms. And because of the study of those discrete energy states, it became known as quantum mechanics. Just a little trivia there. So looking then at this red color, we're seeing the recombination of electrons jumping back down into the hydrogen atoms and going to level 2, energy level 2. All right, that's what this is right here. Really amazing place. This is the Eagle Nebula, Messier 16, and you can't see it with your eye. In a dark area, you might be able to get a hint that there's something there, but beyond that, you won't. But one that you can see with your eye is this one. This is the Lagoon Nebula, and this one is in Sagittarius, and this is a nebula that beats all other nebula. This nebula is besides the Orion Nebula, this is the next favorite of anybody. Why is that? Well, just look at it. Look at this dark nebula over here. There's dark areas over here. Star formation is rampant. There's all kinds of things going on in this nebula. This little feature right here that I'll zoom in on, this little hourglass type feature right here, this is an O-type star, right? That's the hottest and bluest star there is. Believe it or not, this star is what powers this nebula. I know that seems odd. I know that's hard to believe, but and that seemed weird. Okay, I thought the nebula went out. I know it's really hard to believe, but this star powers a great deal of this nebula. These stars certainly assist, of course, but isn't it crazy? Isn't it beautiful? I think that's pretty amazing. So we're gonna try Keith another time now. So pardon me for the stupid noise of Skype. Bum bum bum.
Heyo. Heyo.
Ding 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 ding.
Stupid computer.
Yeah, you're back now.
Yeah, it's a freeze for no reason.
Wow. Well,
everything just froze.
Oh, it was cold out. That's why.
I have no idea. It's time to upgrade.
Yeah. Well, I was talking a bit about the Lagoon Nebula here. This is Messier 8. Okay, and you can see these beautiful areas within the nebula. They're just beautiful. It's almost like a painting, isn't it?
You want to share your screen again?
Oh, I would like to.
If you can.
Will you like me to?
It's a little bit easier so I can talk to you about what's going on in real time.
Okay, there we are.
There we are.
So you can see it now.
Yeah.
So now, yeah, this beautiful, like this area is, like I was just telling, this is the area where the O star that powers the nebula is located. A beautiful location. And then, as beautiful as this is, though, this is like I said, a deadly place for us. Deadly place. We would not survive here. We could not survive here. It's just absolutely chaos with ultraviolet energy. Yeah. All right. And here's another area here. This area right here. Check this out. Okay. This area here. Notice these convolutions in here. All this dark gas here and dust actually. And then these little beautiful clouds upon clouds. These are all star formation locations. And like in these dark areas especially, these are like the dark areas where these globules are. Here's one right here. Look at that. This is a dark globule. A little bit elongated. Maybe it's what's called a propylid, where the stellar winds from something nearby, one of these stars, is actually possibly blowing some of this dust away with its stellar wind. And maybe this is a solar system, a star system of some sort in formation, underway here. Amazing. And that's Lagoon is famous for its tremendous variation. If you notice, here's a very dark area here. Okay. These are not spots on our lens. Okay. I do have some, but these aren't them. But these areas all here, the dark areas are the ones that intrigue me, because that's where the actual star formation is going on. That's where it's all happening. Just incredible. And I want to see if I...
Active photo.
What's that?
It's a very active photo.
It is, isn't it? It absolutely is. Yeah.
A lot of stuff going on.
Oh, yeah. Absolutely sure. Absolutely for that very reason. Yep.
Got that nice little perp skirt color.
Yep. Yep. Okay.
Amazing.
Ted, I don't remember actually how many light years across it is. It's got to be at least 30 light years across. I'd say maybe more. So I don't quote me on that, but I think that's probably what it is. Now, if we go to the opposite of stellar formation, then we end up going to stellar destruction. This is the Crab Nebula. Oh, good night, SF. Thank you so much for joining us tonight. Very nice to have you here. So this, in 1054 AD, the Chinese noticed a new star in the daytime sky, and it was this star right here, going supernova. All right, and in the heart of this particular supernova remnant, that is this star that exploded, we see the remnant, and we also have what's called a pulsar. It's a brilliantly flashing, like 30 times a second, star that's rotating so fast that that beacon of hot radiation is flashing by us, as I said, many times per second. And over 100 years, we've actually seen this expanding outward, and the view is immensely different. You look at it in the beginning, and you see filaments moving outward over 100 years. It's amazing, And we're not taking pictures all the time. It's just like every so many years a picture will be taken, and when you compare them together, they look very different, So yeah, this is neat. And so the best thing I can say about these supernova remnants is that I'm just very happy that we're nowhere near them, because we don't want and would not want to be near any kind of a supernova if it went off.
Well, what is Betelgeuse, right? It's due to go supernova in the next 500 or so, right?
Well, if it didn't already. Okay, but the thing is, it's 497 light years away, right? Yeah. So it's actually pretty pretty far away, and it wouldn't affect us that far out.
No, but it would be beautiful in the nighttime sky.
Oh, you betcha.
It'd be really, really bright.
Yeah, it would, and it might be probably seen in the daytime sky too.
Yep.
Now, we don't know about this one. This is just a section of the overall Veil Nebula, but this is a supernova remnant in Cygnus, and it goes down and completes nearly a circle, and you can actually see it in the sky. I'm, of course, not going far enough out because I can't, because you won't see the cursor, but you can imagine, just complete the circle, and there's another side to it, and if you notice, you see this beautiful oxygen 3, this doubly ionized oxygen here, which is the greenish glow, and then the hydrogen in here, and as that material, this gas, moved out from the star in the supernova, it collided with other stuff in the interstellar medium. What do I mean by that? Well, as you look,
it looks like smoke from a giant space cigarette,
doesn't it though? Okay, and the thing is, you can actually see where these filaments have these are like shock fronts, where they get bunched up because they're hitting denser stuff out in the interstellar medium, and they get slowed down, and so they bunch up with each other. I mean, it's just incredible, so and this supernova remnant is one that we saw, and when I saw this for the first time, I saw it in SkyTour LiveStream last year, and I don't know, maybe I don't know if I cried, but I think I was I'd never seen it like this, and when I saw it, I was beside myself. I tried to maintain my composure, frankly, but I had never seen it before, and it was just beautiful. I always knew it was there. I always tried looking for it.
Name this the seaweed cluster.
Let's see. Well, the
seaweed at the bottom of the ocean.
The nori cluster, right?
Yeah.
Yeah. So that's really cool, and that of course is the Veil supernova remnant. And then that's one side. On the other side is this beautiful spindle. This star is called 52 Cygni,
Oh, that's definitely a space cigarette.
Yeah, well, exactly. This is interesting too. I mean, this was a really interesting. This is the other side of that veil.
Is that red
in Las Vegas?
Why are you offline?
I'm not.
Just came back on. Never mind.
Okay.
It went off for a second, then came back on.
I don't know. I had perfect stream health here.
It came back on at 240p. Get out of here. Back up to 720 at least.
Is it?
Was that what it was? An ad? TD?
Really?
Yeah, no idea.
An ad came through?
I didn't see an ad, but...
Oh. Hey, Dee Dee. Dee Dee's here.
Yeah, YouTube's known if you go over an hour, they start putting them in whether you want them to or not.
Oh. Well, that's no good.
Yeah.
Yeah.
Yeah, I don't think there was an ad, unless somebody did.
Yeah.
I know that we have ours set up where you get like a little 5 second, like an ad when you first click on. But,
yeah.
You know.
I mean, I can understand that, but while you're streaming, they would actually do that?
Oh, when she came back, she got it. Yeah, so her stream stopped too. So yeah, it had to be something from the broadcaster end. Wasn't just me then. But it could be YouTube messing up too. So
okay.
So I don't see nothing in your OBS that would have.
No.
They're missing frames or anything. So
and my encoder is not being overloaded either.
Nope.
Interestingly enough, thanks to your assistance.
Hey-o.
That's right, man.
Right now you're buffering.
I am.
Oh, just on my YouTube. That's. I mean, once again, it could be the server from YouTube. You never know.
Well, it could also be that you're getting this gigantic screen scrape of everything going on at my end as well.
Could be, but I have pretty fast internet.
No, that's true.
But I refreshed it and it came right back, no problem. Now Laura's buffering. Yeah, so it's something with YouTube. It's something with the intake. I don't think it's on your end either, Mark. I think it's something with YouTube.
Okay.
But no biggie. I mean, if they just F5 it or refresh it,
yeah,
it came back pretty quick.
Yeah. Every time you talk, I'm hearing like you've got your volume up on some other thing. Like you have the stream up on your volume or something?
Up?
Do you have my stream up in YouTube at all?
I do, but it's muted.
Okay, that's odd.
Maybe you're hearing it come from my headphones?
Oh, maybe. I don't know. No, I have no idea what happens with these things sometimes. Wow. Wow, man. It's crazy.
Hello, Dee Dee.
Yeah, Dee Dee's here. Yeah, I love it.
I could try turning my headphone volume down. Maybe the microphone's picking it up from that.
Oh, I don't think that they're that sensitive to pick that up, are they?
I don't know.
Oh, okay. Well...
Yeah, I hear the music too, and the music's like got louder.
Okay. All right, here's another one. This is the North American Nebula that we took here. Again, exceptional clarity. If you notice, this is in Cygnus the Swan. In August, it's directly overhead. In fact, the North American Nebula, from Connecticut anyway, is directly over your head. In August, but look at this detail. You can see the feathery wisps fading into the darker nebula that's back here. Star forming region down here. So much detail here. It's just an incredible location. I was stunned when I saw this come out like this. I was absolutely stunned. You know. Just beautiful. The North American Nebula. This is a close-up of the Mexico part.
That old Chinese dragon art.
Yeah, right?
You know?
Kind of looks like that. It looks like that, doesn't it? Sure does.
You can kind of see, like, well, I mean, I don't know.
What's
where
that?
A lot of inspiration comes from. You know?
Yeah.
Can you imagine like being like back in the 1600s or something, looking through these crappy old telescopes?
I think that if I was back then, we'd probably be, wow, this is so cool, you know?
And they thought that was like the coolest thing.
They did. Looking
at the moon surface.
Yeah. This is the entire North American Nebula now, obviously given the name because here's North America, Florida, Mexico. And that picture I showed you just before, that was this area right here. That was the Mexico area that we looked at earlier, right here. And I had processed it, and that's what we saw earlier, moments ago. So that is the North American Nebula that's directly overhead in August from Connecticut. And the North American is beautiful. It's again a beautiful emission nebula, called a diffuse nebula actually. Just absolutely stunning. Now in the middle of Cygnus, right in the heart of Cygnus, that's the Northern Cross. Well, the central star in the cross is Gamma Cygni, and this nebula, this is Gamma Cygni right here. This is a nebula that's right near Gamma Cygni, and it's another beauty. And this is just stunning. And when I saw this for the first time this was taken with a 5-inch refractor as well, mounted on our system, and it's just beautiful. All this detail in here. And normally what I do is I actually subdue the stars. I lower their brightness a little bit and leave everything else brighter to make it more realistic. But I just saw this glittering jewel box of stars with nebulae, and I just had to keep the stars bright. It was really pretty. But this is the Gamma Cygni Nebula. It's just stunning. Again, this is Cygnus in the summertime sky.
Yeah.
But there's so much. There's so many things. And
this isn't even scratching the surface.
Oh no, it's not.
This is pointing out, ones that stuck out.
Yeah.
You can go a whole year just pointing out smaller things.
That's right.
Yeah.
And this is the Dumbbell Nebula again, but this is a one-shot, meaning this was the one photograph that I took. I didn't take many photographs. This is just one. And give you an idea, I'm just gonna give it a little bit of brightening to it just now.
While you do that, let me ask you, what RAM do you have in your computer?
I have.
You have like a i5 core or something in it?
Yeah, it's an i5.
Is it?
Yeah.
I'm thinking about going to the i7 core.
Yeah, I have an i7 in the observatory actually. The i7 PC's out there that runs everything. We're actually linked to the i7 actually throughout our SkyTour LiveStream.
Mm-hmm.
So I have that i7 going. Plenty of
more processing power. Yeah.
Yes, it's generally faster. The i7 core is next generation, from the i5.
I did find a new tower that had like all the upgraded, image cards and all that stuff, and it wasn't bad. Like for the i7 core and whatnot, and it had like 1 terabyte of memory, and it was, I think it was like 749 or something like that.
But you'll find
the tower. I don't need like the keyboard and all that crap.
Yeah, but you know what? The keyboard's like $6.
Yeah, but this place isn't a sponsor at all by any means. But man, if you want really good computers at really good deals, there's an actual website called Buy Power, and they actually custom make desktops and laptops and whatnot. And their desktops are amazing. That's where I got this one at, and I'm probably going to go back because they're basically, they always update it, and you can custom build it with your own stuff, or they can do pre-built ones that it's always the latest top of the line stuff, and there's really good prices. Really good.
Very cool.
Yeah. So once again, anybody looking for a computer, DD, wink wink.
There you go.
Just in case. Do not be afraid to check out.
Do not fear.
The Buy Power. Yep.
Yeah.
I can actually put that link in there for anybody that needs it.
Nice.
Really good service too, and warranties.
That's good.
I don't even know why I'm propping them up. But still, everybody, especially if you're into astronomy, you definitely want, and you're going to be streaming, whether it be gaming or something like that, you definitely need a computer that can handle it.
Yeah, that's true.
Yeah, and this goes for anybody in the chat that's, astronomer, at home, may not stream or whatever, but yeah. That's the stuff they go with, and I love them.
Nice.
Yeah, it's almost as good as the place that we all got our cameras from down in Jersey.
Oh, you mean from the guy that Bill?
Yeah.
Yeah, that's wasn't that Wayne?
What's that?
Is that Wayne? That's Deals All Year.
Yeah, Deals All Year is a good camera place.
Yep.
Yep. And then of course Paul does really good business with was it B&E, B&G?
B&H.
B&H. That's what B&H Photo.
Yeah, B&H Photo. Yeah.
Business with them. And then of course our old cooter.
Yeah.
Up in Canada building the moon cams, but
Yep.
But the guy, old cooter with the moon cams, gets a lot of the optic stuff from B&H. So
yeah, very cool.
Place.
So I actually wanted to show a few other shots too that didn't really relate fully to what we're talking about tonight. I want to show this one. Okay, this is a shot which you should recognize because you were over here where those lights are.
Yeah. Where'd you take that from? The route heading into town?
I did. This is actually in Wyoming, folks. This is Devil's Tower National Monument, where Close Encounters of the Third Kind was filmed, and where, of course, Doug Trumbull is the one who did all the special effects for Close Encounters.
That place is humbling, man.
Yeah, and we've been talking about Doug actually on and off tonight, all night. So
you should get him on tonight. I'd like to talk to Doug if he was ever available.
I'm sure I could drag him on. He'd probably come on. You know, he's a real night owl, kind of like me. So,
well, I've seen him in that interview, and he seems like he can. I mean, this is just me reading from the outside. He seems staunch, but he seems like he's approachable.
He is. He's like your grandfather. I mean, when I see him, it's a big hug. Oh, hi, Mark. You know, it's like, you know, it's not shake hands and very formal. That's how I was when I first met the guy. I was shaking, actually.
Yeah.
I think I told you the first time I worked for Doug. Raymond, thank you, man. Hey, look at that.
Raymond must have got his tax return.
He's gone green, man. Thank you, Raymond. Very cool.
Well, I'll tell you what, that Devil's Tower, man. I mean, that place is so humbling. Like,
it is.
People that live around there just don't realize what they have at their fingertips.
Oh no, they do. Trust me. I know a lot of people now that live there, and I can tell you.
We did convince the people at the campground there to start their own cam.
The KOA down here.
Yeah. So there's a Devil's Tower cam now.
Yep.
How cool is that? That's
very cool. And for those wondering what this is, that's actually an aircraft moving through the frame. And you could tell how long I took the picture because all you have to do is count the belly strobes, which are these guys right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just probably 15, okay? So so these are mandated to flash at 1 per second. So that's a 15-second exposure.
Yeah. Let me ask you, when you were out there, did you ever take say 5 minutes by yourself and just kind of sit in awe?
Oh yeah. You know,
like away from people, away from answering the question, like actually just sit there and just stare at that, and especially in the night sky when you have the Milky Way, bright as bright can be above you, like literally it is humbling. Like you will sit there and just be like, wow.
Yeah, I'm going to show you a couple of those shots actually.
We are so small, it just makes you realize how small you actually are.
Yeah, it's very true.
Next giant object that is just massive in scope and size, and then you still got the Milky Way above that. It's a real personalized moment.
Oh, it is. I mean, it's humbling, and it
done it like tons of times there.
Takes you aback. Let's put it that way. All right, let me. I'm going to find that photo that was the quintessential one for me that made me feel really, really humbled. And I'm thinking this might be it. Let's just open it and see, shall we?
Well, you know us. I mean, we were going like, hey, yeah, we're going shooting live at Devil's Tower, and it's like, you know, the first night there when it was clear, we were just wow, you know.
So here's the picture. This is Devil's Tower, okay, and I'm in the parking lot at 11:45 at night. It's
open 24 hours. By the way,
it's open 24 hours because it's a national monument, and national monuments aren't policed, and I just couldn't say no. I had to come here. So the red you see here is leakage from the camera's amplifier. I have other photos where I've kind of processed that out and brought the photo to what it should be for colors. But here's the Milky Way, okay? And that thing right there is the Andromeda Galaxy. Okay, let's zoom in so you can see. Okay, so there's the Andromeda Galaxy.
Does Laura live out there?
She's in South Dakota, but she was there twice. She saw me speak twice out there.
South Dakota. Oh yeah, we went because me and Paul were out there in late October, early November, and we had the whole place to ourselves and all the Wi-Fi and everything. And it just and then we went over to South Dakota afterwards.
Yeah,
gorgeous area. I would love
the
to
Black Hills. Yeah, you were at Mount Rushmore out there.
Absolutely.
Yeah. In South
you can't
Dakota.
go through there without seeing Mount Rushmore. I mean, come on, that's just.
I've been out there twice and I haven't seen it.
Really?
Yeah, and Laura right now is going, what?
I know, right? I mean, it really wasn't that far. I mean, you're talking about it was about half hour off the main drag there. What is that, 90?
Well, yeah, but when you're out there, courtesy of other people driving you around,
that's true.
You know, you don't have. Thank you, Dude W.
A little bit better, so we're all out there at the same time. Because listen, I don't mind driving. I almost rather drive because I like seeing the country.
Yeah.
Like, not the country as in yeehaw. I mean the country as in the United States. Like, I like seeing, being able to go from a dense metropolis out to the middle of nowhere, literally in 30 miles.
Oh yeah.
It's stuff like that, and it's just stuff you can't see on a plane. Plane's fast. If you want to get somewhere fast, go by plane. But if you want to enjoy it and actually see, this country of ours, drive is the way to go. And I'd rather drive out to Wyoming anytime than fly. So maybe next time we'll schedule it around because you were there a month before us last year.
I know, and we were trying to get there at a different time. When you might have been there, I couldn't do it.
But you had that, you had the MUFON thing in Arizona at that time.
Yeah, I did. I had to do MUFON boot camp in Arizona at the time when you were out there, and you couldn't come down there, and I couldn't go up there.
The plan, the ultimate plan would be to have you, me and Paul, and Bill all go out there at some point for a lengthy time,
Yeah.
For at least 3 or 4 nights.
Oh, yeah. That would be amazing.
Take all the equipment that we can, imagine Bill doing the live sky stream.
Oh, yeah.
There. You know what I mean? That's insanity.
It would be absolutely crazy.
Be totally lit.
Yeah.
If we can get him away and be able to escape the monster that is KGRA.
Yeah.
For a 4-day or 5-day stretch, that'd be awesome. Well, he'd have to take a week because, you're talking about 2 days of each direction of traveling. So,
well, that's for sure.
But if you have 2 people, riding or whatever, 2 people per car, you can switch driving and one can sleep, and it's great. And anybody who wants to join us, maybe we'll do it, at an early time or later time throughout the seasons. That way, there's a lot more spots available.
Well, let's see what Laura says. Do a Black Hills conference. I mean, it's made for it.
Laura, you want to put that together?
She may. Be careful.
Hey.
Hey, look, where else can you go when you can come face to face with this?
Looks like my grandmother.
Oh, wow.
Nah, don't worry about her.
Actually, this guy was very friendly, though. This is, a close-up of him.
Where was that at? Black Hills?
This is Wyoming, yeah.
Oh.
Yeah, let me see if I can... Well, this was a really cool shot. I'm just zipping through here, looking at some of the shots. Caught a satellite, actually, for this particular shot. It's a satellite, not a meteor, because you can actually see that it's a constant light all the way through. This was just on a tripod, just aiming up, but it was just several seconds. Now this, accidental exposure. Notice the lights are on in the parking lot, and if you notice, you can actually see Devil's Tower right here in the distance. I'm 9 miles away from the tower now, at the golf resort where we were staying to do our talks. This is where the Devil's Tower conference was held, and this was a photo that I took actually just off the beaten path, and this photo was a 10-second photo. Okay, 10 seconds. All right, on a tripod, and look what we get. 10 seconds, and look how much Milky Way. And there's even clouds.
But I totally forgot about that. I should have somewhere some 30-second exposures on the point shoot camera.
Yeah, I bet.
And I thought I uploaded them, or maybe I didn't.
Yeah. And this is, of course, Devil's Tower up close. You kind of get a feeling for the scale. Those are full-size trees.
Yeah, that doesn't even do it justice.
You see what I mean? Now you're getting it. Okay, this is a massive, massive rock. Okay. And
you're at the base of that thing and you look up and it's just wow.
Yeah. This was my favorite shot, actually, and I did a number of these.
That's a good one.
Yeah, and you've got some longhorns. You got 2 buffalo.
My favorite shot was the one actually on the P&K Facebook. I actually have it as the banner image.
Do you?
Yeah, it looks really good.
Yeah.
God, I took it, you know, that stop as you're coming down the hill.
Yeah.
You know, that one pull-off spot, parking spot.
Yep,
I took it from there, and it's just beautiful.
Yeah. Now we were here. This was the year before the first year I was there, and the second year I was there was crystal clear. The first year there were forest fires, and unfortunately, if you drove northeast from Devil's Tower, people were reporting that it was snowing, but it wasn't snow; it was ash from the fires. And also here you have the Prairie Dog Town on the Devil's Tower property. Did you see the Prairie Dog Town? As soon as you go through
the Prairie Dogs, right when you go through the gate of Devil's Tower.
Yeah, that's what I'm talking about. Here's where they are.
Is that what it is? Is
Yeah.
that what you call it, the Prairie Dog Town?
Yeah, it is. I mean, it's a Prairie Dog Town. That's what they call it.
All right.
There had to be probably 400 or 500 prairie dogs chirping away. And I took a picture of this one particular guy who was staring. It reminds me of that guy that's going, you know, like, what is it, like, you know, Frank. Hey, Frank. You know, hilarious, you know. But, you know, they were cute little guys. And this guy's like, hey, that's my house. Go away. So I left him alone, but, you know. But there's some beautiful areas here. This was on the other side. Went to the park, too. Not the park. We went past the Devil's Tower, went out to... look at the people. See the guys? Give you an idea of the scale. You can see the scale here. There's climbers right there, guys.
It's a monster.
Yeah, I mean these are giant crystals of basalt. Actually, not. It's a different type of. It's close to basalt. And they're like 11 or 12 feet across per crystal, and they fall. They actually crack and fall. You can see here, over here. There's one that broke off and fell. Okay, and people have throughout history said, well, this looks like, you know, it's a giant tree stump, you know, because of this. Well, here's the chronology of what happened at Devil's Tower, and it speaks to the way the Earth was formed. The Devil's Tower, this part up here, you'll notice this actually is weathered pretty badly. See how it looks more weathered up here than here? There's a reason for that. It's because this has been exposed for longer than this. And we say, well, how is that possible? Okay, and there's a very complete break here. Look at that guy. It broke out and slid right off. The reason this is like this...
It almost reminds you of like a wasp thing, or what is, I think that's what they are. Don't they, like, you ever see like a wasp nest on the side of like a wall or something?
I mean, the mud daubers.
Is that what they are?
Yeah, and they make the little cocoon, little thing that they crawl up inside.
Yeah, it does look like that.
Yeah. But this was actually... This entire area, right up here, used to be the ground level. This is over 800 feet over your heads. And this was ground level. And over time, it eroded and exposed that much at first, then this much, and then finally, the amount we see. And that's what all this stuff is around the base of Devil's Tower. It's the eroded material from the soil. This is how much 800 feet worth of ground has been eroded away, and this was a hard magmatic intrusion that never got through the surface.
Straight out of Game of Thrones.
Maybe, huh?
A 700-foot ice wall. There's well,
yeah.
That one's about 500 foot, right?
Yeah, this is, yeah. So this is actually, this fluted appearance is actually due to the, as I said, to the way it cooled underground, all right, and it was exposed later, and that's why it appears the way it does, like this giant thing sticking out. Why is it alone like this? Because it's hard. It's very hard material relative to the softer sedimentary rock around it. This is a rock, you know, that's created by volcanic processes, so it's very hard. So here's the grassy area surrounding Devil's Tower. It's really a fun area, and I went out there to view the sky the second year, and it was just absolutely stunning out there, you know. And
if I knew I could afford it, I would so move out there. Like if I knew if there was work available enough that, you know, would keep me.
Well, here's the thing, Keith. There's people out there that have told me about, you know, you could live out here and you know, we can help you find someone and all that, and you can get a place. And I'm all for it, except for one fact. They get winter, and it's an absolutely brutal winter, okay?
Well, you know what? If you're out there and you're, you know, if you set it up right, you know, there is a way to, you know, do the pros outweigh the cons pretty much.
Oh, I don't know. You're gonna have to.
Like I'm guessing the older that you are, wink. You know, of course, warmer climates would definitely be.
I'm not a retired to Florida kind of guy. I'm a retired to the desert kind of guy.
Well, nobody should be retired to Florida anything. Have you seen the crazy news coming out of Florida?
No, I haven't. Why?
Yeah. Well, first of all, either everybody's 8 or 80. Number two, the country's craziest newspaper headlines come out of Florida.
I guess that's true, huh?
Face to it, Florida is just, it's there for entertainment purposes only. I think.
Oh, that is so funny.
It is. It's crazy. Like
that
all
is so funny.
And Paul will be the first one to tell you that. You know? And it might be because of the warm weather.
Maybe so. Maybe so. Maybe so.
Yeah, I mean, the only reason really to go to Florida is like because of Walt Disney World. And even that in the summertime is like overly crowded, and you're gonna have a bad time.
Yeah.
Like wearing boxers with jeans.
Well, this is the SkyTour LiveStream Observatory, taken one night when we had a beautiful night. There's the 5-inch refractor on the main instrument, and I know that
He said Florida's ratchet.
And I think that I think this is where we're going to call it, because unfortunately, you know, we don't have our clarity any longer tonight, which is really sad. I really want to. I'd really like to continue the stream, but without our beautiful night sky,
Hey man, sometimes it's cool just to hang out, you know.
Well, yeah, and I don't think people are too upset that we can't do the full hangout tonight.
No, we got a bunch of cool people in the chat.
Yeah.
A lot of regulars, you know.
Yeah. Yeah, a lot of people. Yeah, and I want to thank a lot of you guys for coming out. And
well, what do you guys want to talk about?
Well, yeah, it's,
you know, we got a little bit of time, a little bit.
I think so.
Yeah.
You know,
I mean, clouds won't deter us. Anything you ever wanted to know about Mark or myself or?
Wait, whoa, hang on. What do you mean?
Just ask.
That's a joke. I'm kidding.
You know,
I just want to see. I haven't gone out to look, so I'm just gonna try and just see if there's anything to see.
By the way, if anybody of these nice subscribers, whether it be P&K or Mark's or Bill's channel, does web design, we're trying to figure out a way to update our links on our website, you know, easier than what it is for us to have to do it every time we go live.
Oh yeah, that's true.
If anybody can help us figure that out, that would be greatly appreciated.
Yeah, we would love that. We need help with that. Well, tell people what the problem is too, because I don't think they know.
Well, the problem is, see, we have a permanent live link for, you know, when you go live stream, and it has a C in it, so it's like, you know, P&K Space Imaging /C/live, and for some reason, Wix, the website that we use to host it, does not accept that.
Yeah.
And so every time we go live, we actually have to go and update with a new link every time. And we're trying to find a way that be a permanent live link that it will automatically stream to the website. So, yeah. And you did have a question from Maddie, which is, what are Mark's other passions besides astronomy?
I still do magic. I've been a magician for many years, decades. and I do close-up magic, so hand manipulation stuff, you know, where you're making coins disappear right in front of people's faces and stuff like that. So yeah, I always actually work these magic tricks into my talks. Actually, Laura's seen some of the magic stuff we did too.
But
what's that?
It just keeps wanting a buffer for some reason. I mean, it comes back on, but it just every other second it's buffering. I'm not sure if you turned on some other cameras or something.
I just turned on my dome cams again. You know, so that's about it. Actually, I'm gonna take a picture here. This is I wasn't expecting to have anything.
Amal, email me at pkspaceimaging@gmail.com, and we'll see if you can help us out trying to get that with permanent links for Astro Imaging Live.
That's great.
Let me see what you got here. You got, you haven't, but your encoder's still overloaded, so.
Oh, it says so again, yeah.
Yeah, so that might be what's doing it. So you might have had to start and stop again just to make it flush, but you're almost wrapped up here anyway, so.
Well, I was, but now I'm noticing that,
well, here, do this real quick. Just go to stop stream, and then once the start comes up, then hit start again.
Won't that just make a whole nother one?
No. You have 30 seconds until it makes another one.
Okay.
Yep.
All right. Well,
stop.
Okay,
Yep.
now I did.
You're good. See what happens. And I'll just tell people right here, just in case. Because, mine never takes that long.
Oh.
But I'll go to this, and I'll go to that. And voila, we are back live.
Oh.
And now let's see, computer usage should be up 30 frames, blah, blah, blah. Okay, everybody. Let's see if that helped anybody out. You might have to F5 or refresh, just because this took a little longer for some reason. But besides that, you're a lot smoother anyway.
Well, my encoder is still overloaded.
Yeah, that's weird.
Huh.
What are you feeding into it? Oh, you know what? Oh, because you use all those scenes.
Well, not at the same time, though.
Do you have them on, make sure they turn them off when they're not in use?
I don't know where that is.
On each one of your sources and each one of your scenes, like each one of your sources, there's a little thing that you can click that says disable when not in use. If not, those programs will be running in the background in OBS constantly.
So where do I see that?
If you would go to properties on any one of your sources.
So, I mean, sources over here?
Sources or scenes, either one.
Okay, let's.
But I know what happens in sources because sources is what I use. I don't really use scenes all that much.
Okay.
Yeah, see, they don't even give you a thing for properties. But in your sources, yes, they definitely, any one of those that is not in use, just have it when you minimize it, it shuts it off. That way, it's not running in the background the entire time. Because if not, then OBS is trying to encode that information as well.
Well, I did properties. It doesn't show me anything.
Multiplayer capability. Oh, it might be different because it's a TV viewer.
This is a 64-bit version.
Yeah, all mine have that thing that says disable when not in use.
Huh. By the way, did I start a whole nother stream?
No, you're still on the same one.
Even online, it's not. It's the same one.
Yeah, on YouTube.
Okay.
Yeah, as I said, you got about 30 seconds before they make you do a new link.
Okay. This is actually the Ghost of Jupiter, just so people know. It's actually a planetary nebula. And I'm taking advantage of the fact that there's apparently a hole in the clouds right now to check it out. It's also known as the Eye Nebula. All right. And as a planetary nebula, it's showing that characteristic bluish teal ionized oxygen. It's actually oxygen. They call it oxygen 3. You might say, well, if it's ionized, shouldn't it just be like oxygen 1 or 2? You know, for a singly ionized, shouldn't that be oxygen 1? You know, and doubly oxygen 2. Well, you might think so. Okay, but chemists, like astronomers, like to confuse you. So, basically, what it is that we're looking at When you see oxygen 1, it means the base state of oxygen where it has all its electrons. So oxygen 2 is singly ionized oxygen, and oxygen 3 is doubly ionized oxygen. Yes, it's that crazy. You know, this greenish color is related to the fact that there are light clouds currently.
Man, it is.
But
isn't it?
Huh? What was that? Yeah, it's. I mean, we're not seeing it the best we can, but I'm gonna go down to say 5. And I'm gonna actually drop the ISO actually. So I'll drop it down to say 4,000, 3,200, and then go up by a couple orders of magnitude. So 8 seconds. Why? I'll show you. Less noise, similar image, and we'll be able to see maybe the central star in the planetary nebula. Okay, that looks a little better. You see the noise abatement going on there. And now let's just go over to our view and zoom in a little bit. Oh, look at that. You see the star? It's beautiful. You can see it. You can see that star, and you can see how this particular nebula actually kind of looks like has rings, like little rings around it. But look at that. Right in the middle, there's that star. It's there, and that's the central star of this planetary. The remnant, okay, the white dwarf in the middle. Or, as we may think now, the Wolf-Rayet star, but probably just the white dwarf in this case. But that's the ghost of Jupiter. Beautiful. Okay, so now, while we're here, might as well take advantage of this. Let's go, that's pretty low. We did this before. I looked at a few other things here. We actually were streaming yesterday, which was really good, and it was nice to be able to stream yesterday. And I think if I don't miss my guess, we actually.
What is up this music?
Huh?
Am I hearing like double? Now I'm hearing myself.
Oh, I don't know what you're doing.
I'm not doing anything. I think the computer's loaded.
You think what?
I think your computer's loaded.
You think so?
Yeah, because you got to remember that CPU usage, that's what OBS is using, not what your entire computer usage is.
Okay.
And it's using 54%, so it's leaving your entire computer, everything else to run off of the other 50.
Gotcha.
So.
Yeah, I don't.
I hate to say it, but I think it's a good time to wrap, and then we can work on this OBS just a tad, just to get you set up for future stuff.
Well, I mean, if
unless you all want to go through this with us.
I don't know. I have no idea actually what's going on per se.
I can tell it is coming from your end there because all your stuff is like it's like sketchy. Not sketchy, but stuttery.
Not here.
Actually, turn off screen sharing and see what that does. See if that helps.
All right.
Maybe that's running a little bit too much. I'll just watch on the YouTube feed.
All right, so let's do that. Okay, and let's see. All right, I'm stopping the screen sharing.
All right. Very good. See if that helps you out at all. Because I know it was buffering again. And let me do a quick F5. But yeah, I think you just have a lot of stuff running. And I think after a while, it starts taking its toll. So, like when you first start up, the first hour or two is usually probably okay. And then, because mine used to do that, my last computer.
Maybe so. Maybe so. Can't say no.
Yep. Thanks, Amal. I'll check it out once done here tonight, and I'll respond. I'll talk to the guys and respond and see if we can't figure something out for astro imaging then. So thank you, sir.
All right, I'm gonna go see if we can go check out. If you see that we're moving.
We'll see you later, Laura.
Laura's heading out?
Yep.
Okay, Laura, thank you for coming by. Thank you so much for your support. And I'll talk to you about Vegas and Laughlin as well in the coming next day or two, yes? So I will see you a little bit later. This one may not come out because we might be impinging with the dome a little bit.
Yeah, you're buffering bad now. Is it buffering for everybody else bad too? If you can hear me between buffers. It might be that time, Mark. I hate to say it.
No worries. I think you may be right. You might be right.
But I would love to get this figured out because your computer is more than enough to run that stuff. I think we need to get your OBS usage down around 28 or so. It should, like most guys aim for 25%. You know, okay. Unless they have like a really, really fast processor. And usually those, you know, are the ones that I posted a link earlier. I mean, they're super processors.
Yeah. All right. Well, hey, you know what? I think that probably a good idea to follow through on Keith's suggestion. We will wrap for tonight, and then we'll come back after we optimize the machine a little bit. How's that? All right, and not tonight though. But yeah. So I want to thank you guys for
thanks everybody for hanging
coming along for the ride. It's been a lot of fun tonight. So we'll talk to you in the next couple of days. Hopefully it'll be clear very soon. So say your good nights because we're going.
Thank you, everybody.
Thank you guys for your generosity. That's amazing. So we will talk to you in the next couple of days. I actually have some more ideas for other things to show you as well. So it's Keith and I signing off. I'll bring the music up a little bit, but then we'll fade it away. So Good night, everybody.
Yep. Be safe, everyone.